alpha diopter. So this is generally typical. This means that we are introducing a chromatic compensation. And now we go to the total corneal power. So here we consider also the contribute of the posterior. And the posterior, of course, provides a negative power, negative contribution. But once again, when we see now the power of the cornea in the entire, basically, contribution, means anterior and posterior, again, we are used to think to 42. Once again, the number, if we make the inverse of 42, is 23. Again, on theory, no lens. While, on the contrary, if we make the reverse of 30, 31, we see that we still need the lens. So further confirmation that the total power of the cornea ranges basically in between 30 to 34. And again, we can detect the refractive power of the posterior as a difference in between the total cornea and the anterior cornea. And what we see is that the power of the posterior, in a case like this, where you see it's quite regular cornea, ranges in between -2 to -6. But again, this is the posterior shape of a cone. And here, of course, the posterior shape, as you see, acts in a negative way, but now with a very strong chromatic effect, is much higher the negative power where is the cone. And here we understand in a clear way the contribution of the posterior, which mitigates the aberration of the anterior shape. As a consequence, ray tracing is of a paramount importance if we want to improve quality of vision, because basically if we are going to remove completely the cone from the anterior, you understand that we are inducing an opposite chromatic, which basically is caused by the posterior shape. So if we basically analyze in detail with a very tiny grid, each 50 micron, how the beam are refracted, we may basically define, as you will see later on, because now we are just still studying the cornea, but you may intuitively understand that ideally we need not to remove completely the cone from the anterior, but leave some cone to compensate for the posterior. And again, here, the importance of the ray tracing. Here we are looking at ray tracing as a tool to analyze. Now we are just studying the cornea. We are not still modeling the cornea, but just analyzing it. And if we also introduce the contribution of the lens, now we see that the total power, including the lens, ranges from 40 to 45. But we go to 40 to 45 thanks also to the contribution of lens. And in fact, you know, ideally, the lens, if we take the lens and we put the lens in the water, we know the average power of the IOL is like 20 diopter. But we need to consider that where it is placed, the refractive role that it plays, it's around 10 diopter, because of course it's much closer to the focal length, okay? So now, I mean, if we go through all of the refractive surfaces, what we may calculate is the best focusing distance, which is basically the distance where all of the points, they converge. Of course, in a perfect eye, the convergence is not a very one point, but what we need to do to calculate this point is to make, again, an analysis of the point spread function and calculate which one is the distance which minimize the root mean square of basically the error. So, you know, I mean, what we are looking here is analyzing in z distance and looking where all of the points, the best possible focus, okay? This is basically the focusing distance of our eye. And if we introduce, of course, the spectacle, what the spectacle does, move the best focusing distance on the retina, right? Now, if in the software we also introduce the biometric data, we do biometry, what we can do is analyze if basically the best focusing distance is coincident with the axial length of the eye. Because basically, if we say, for example, the refraction of this patient is -3, -2 at 180, and with such a measure, we get a focusing distance, for example, of 23.8. And on the contrary, the axial length of our biometry, say as 24.5, well, one of the two is wrong. So this is a very important tool, which basically may give us a feedback to double check the refraction. Now, what we did up to now, we used the forward ray tracing to analyze basically the refractive properties of the cornea. Before now, to see how we use ray tracing to remodel the shape of the cornea, so to correct for the error, I would like to know if there is any question, if we want to open. Okay, please.
10 this morning, the Earth was a globe. And now you turned it into a torus or into an iconic. So where we live, and an eye has an optical power of 60 diopters. And of course, this corresponds to a focal length of 16.7 millimeters in air. And now before go into all these details, just remind me, why is this approach wrong?
Very good question, Claude. Thank you. I mean, again, you know, if we are looking a lens like the cornea and we put it on the air, you are totally right. But at the end of the day, what we are, you know, I'm an engineer, and what we need to look is the reality. So we need to measure the power of the cornea in the real world where it acts. And in the real world where it acts, we have air in the front and water in the back. And if we do ray tracing, this is the result. But also, it's quite, I mean, when you do cataract, you know, if you have a patient with an axial length of 33, 34, do you put any, your IOL will be almost zero, right? Now, in such a case, if basically the power of, and you have just the cornea, right? Now, how would you explain if you do the reverse of 42, it will come 23? But actually, the axial length of this guy is 34, and he see well. So this is what I would like to grab your attention, right? So it's not basically a lens in the air. We have water on the back, and we need to consider it. That's it. So basically, when now we do, why this is important? Because you will see now that when we remodel with ray tracing, and why we came to the ray tracing, because now, considering dealing with very complex cornea, we need to leave basically the ideal laconic shape, and we need to go with an ideal shape which matches the needs of the posterior and also of the lens. You will see in the pseudo-phakic what we are doing, but you can do this only, again, if you trace point by point, and of course, they have to be a lot of points. Of course, another one very important point is that you have to have a very accurate definition of the shape. Vice versa, it does not mean anything. But I don't know if my answer was enough for you.
Is based on an ideal cornea, or did you consider the refractive role also of the tear film?
Good question. You know, what basically we do is to consider all of the elements, basically with their refractive index. Coming to the lacrimal film, Vincenzo, what we really want, we want to take our measure completely independently from the lacrimal film, because as you know better than me, if we consider, and in fact, Precisio, our tomographer, different than your CT, because you use scattering, it's completely independent from the lacrimal film. Thanks for your question. Absolutely. Because basically, Luigi, you know, when basically you use an OCT, you are working in the infrared wavelength. And you are looking as a signal the difference of density of the media. And as a consequence, you cannot make distinction in between lacrimal film, water, and basically epithelium. What we do, we use a blue laser. The reason we use blue is because the blue provides the highest scattering of the epithelium. So it's much clearer the definition in between epithelium and stroma. And second, we use the scattering. And I don't know if you know it, but I will tell you, liquids, they do not do scattering. So we don't see at all the epithelium, okay?
I think to help Claude, I think if it's right, the lens and no lens in pseudo-phakic patient, they will not have, let's say, 20 diopter power lens that you insert in the eye. With ray tracing will not be 20, will be different. So it's just terms of a matter of numbers, but they will be different, the cornea and the IOL.
Absolutely.
Right? So
totally. And for
this means that if your cornea is 42, that you're putting 20 inside, not 20 is not 42. So that would be 32 and probably less. Yeah. It's just because the difference is in terms of you know, nomenclature. I don't know how to say, but it's in terms of in terms when do you calculate in air or in water or whatever it is.
Perfect. Also, just consider it. If you want to compensate a toricity on the cornea with a toricity on the IOL, you need a much higher power in the toricity of the IOL. I would not say double, but almost. But the reason why is exactly because it's in the, not only it's in the water, but it's much more closer to the focusing point. And again, only with ray tracing you can really measure it. And actually, in September at the SRS, we will launch a software to calculate the power of the IOL, but this we'll discuss in a different meeting. Okay, so let's be focused now on what we are doing right now. So any further question, or we can go ahead now with the reverse ray tracing? So let's move forward. Now, basically, we did the analysis of all of refractive contribution. And what we do now? Now we start from the best focusing point, ideally, and we come back through all of the surfaces. Of course, when we come out of the anterior shape of the cornea, our beam will not be parallel as we would like, but they will have a deviation. And the deviation will be much more stronger as higher is the aberration in a such point. So what we can do? We can build an ideal shape which basically will define a profile which will bring all of the parallel once we remove the tissue included between the anterior shape and this ideal shape. It will bring all of the ray parallel. And now you understand that we are taking as a consequence the contribution of all of the surfaces that they come before. Actually, here you see a regular ablation because the posterior is quite regular. But in a case like the previous one, where you see the posterior is a bump, and generally the bump of the posterior is much stronger than the bump of the anterior, then when we design the ideal shape, there will still be basically a chromatic effect on the anterior, which basically will allow, you see, now the ideal shape is still an irregularity, much lesser than before, of course, but again, this will help us because basically we will remove less tissue and will same time optimize the vision. So this is the process that we follow now in CIPTA Web. But let's see even more what we can do in pseudo-phakic eyes. One, we have, of course, I'm discussing, of course, in a case where you have a relevant ametropia after basically a cataract surgery. And what we can do here is basically make the ray tracing, but now introducing also the feature of the IOL. And what do we need in order to basically make such ray tracing? Well, of course, what we need to define the shape of the IOL, but also we need to define where the IOL is located. So what is needed here is a pseudo-phakic biometry. And the pseudo-phakic biometry will provide us the ACD, the lens thickness, and of course the total axial length. So this information are enough to locate the IOL in the space. But also what we need is basically the power of the IOL, the index of refraction of the IOL, and the design of the IOL in the terms if it is a symmetrical biconvex or a plano-convex. This will allow us now to define the shape, and as a consequence, there will be also one presentation this afternoon on this case, and we will have also a live surgery in a patient which has this kind of situation. But now the ideal shape will not only take care of the contribution of the posterior cornea, but will also take care, for example, of the toricity of the IOL. And again, the ablation will be designed exactly with the same logic. Finally, just to give you basically a first overview of the further release that we will introduce at the SRS in September, the yaw planning. So now we use the ray tracing, and I'm basically this will be extremely important when we deal with complex cornea, where you know better than me standard formulas, they fail, and they fail also in a quite relevant way. Here, what we do is basically introduce the biometry and, of course, a detailed information on the cornea. And what we need also to define, we need to define which kind of IOL. So if it is just spherical or a spherotorical IOL. And again, minimizing the point spread function, this will deliver us, as you see from here, the spherical power, the torical power if desired, and the axis of the IOL. And the software provides, as you see here, the anterior shape of the cornea. On the right, you see the corneal ray tracing, where you see the astigmatism, which is induced from the anterior shape of the cornea. While if you see the total eye ray tracing, you see that, of course, the lens compensate, the toricity of the IOL compensate for such astigmatism, which is also evident from the wavefront. You see the corneal wavefront is quite astigmatic, while the total wavefront is much more regular thanks to the contribution of the IOL. So these are, these are the principles that are on the basis of CIPTA Web. So before now to go to the second step of the definition, again, any question, any point that you would like to discuss?
Are you able to detect tilting of the IOL or a decentration of the IOL and make a difference between IOL and cornea? So this is a total or is just give steps?
Thanks, Vito. Of course, with ray tracing, if we would know the tilting, of course we can take care of it. The point is that actually, you know, even making a pseudo-phakic biometry, not always you have very accurate information. So at this stage, we are considering also only basically the aberration induced by offset on Z direction of the IOL. But, yes, but of course, from this point of view, the tilting will introduce an angle K. And as you will see in the software, we do control the angle K in the cornea, but not induced by basically the IOL, but induced by aberration on the cornea. Eventually, the software can do it, but as you know better than me, we should have a dedicated instrument that should provide this.
Is it actually ray tracing where you send in a beam and collect the signal as in a barometry, or is it ray tracing just in the sense of knowing the shape and then calculate the path?
Good. Well, on theory, there is no difference in between the two. From a practical standpoint of view, there is a big difference. So ideally, if you would be able to have a scanning system that, because what we are doing here, we are scanning in an independent way, where a barometry lacks, because it's not 1 point, but you send all of the beams, and then, yeah, you analyze the feedback of the reflected point. You send one very narrow beam in the center, and you analyze what came out back from the retina. So you have basically, in order to give you an indication, you have all of these, but all them together. And when you have an aberration, those points, they intersect, and you are not able to make distinction in between them. So a barometry fails in the complex cases, because from a technical point of view, you cannot have these point-by-point analysis. What?
There's an aberrometer actually does that, sending in point by point, and gives you, for every single point, gives you feedback. I trace.
Tracy does this, but does not change the angle, my friend. So Tracy, they send one beam, and they just look where it goes. But in order to calculate the aberration, the system is not a linear system. So what you should do is basically change. You see, in order to know it, you have to know basically the entire surfaces. Because being the system not linear, you cannot just say, due to the fact the point go so much distance from the retina, this is the deviation. This is where Tracy lacks. Because basically, you should have a system which sends beams independently, but also change the angle independently. Only in this way you can control it.
Go back to the original question. What do you do? Is it actually sending in a beam and measuring the signal, or is it calculating?
What we do is that we first of all let's consider, for example, the pseudo-phakic eye. Okay, what Precisio provides to CIPTA all of the information on the cornea. Okay, the input in the medical record of the biometry, pseudo-phakic biometry, and of the IOL allow us to calculate the shape of the IOL and to locate it in the space. Now, basically, what we do is exactly what you see here. All of these surfaces are known. This distance is known, so we analyze each point independently, okay? So it's a mathematical reconstruction of the beam, and we see the divergence. But this is basically on the basis of real data, okay? So this allows us to calculate the effective deviation, and as a consequence, we may define the ideal shape to negate such deviation, to eliminate the deviation. This is exactly what we do.
Have you considered also if there are vitreal opacities or opacities of ocular bag, if they are important to calculate the ideal shape of definition?
Very good question. No, the answer is not. We cannot do it. I mean, on theory, we can do it, but once again, you know, Silvio, always, if you know, you all know since me from a lot of years, I always basically, if there is something that we are ignorant, I do prefer to say that we are ignorant, because, but not to basically make hypotheses which may be wrong. In a case like the one that you said, if we could detect it of course, with any instrument possible in an accurate way, the answer would be yes. It's the same question of Vito. Can we consider the tilting? The answer is yes, assuming that the information is right, is correct. Because if the information is wrong, it's better to just say, I mean, I will look what I can do, but I mean, if you have not a very accurate information, it will be a disaster. So at the end of the day, on theory, yes, but in the reality, not.
I suggest that if we have to program something on the cornea, we need also to clear before with a YAG laser, for example, the sealed capsular bag, if there are opacities on before the laser treatment. Don't you think it's better to clear?
I fully agree with you. I would, because also maybe you, if you have, for example, an opacity after the IOL, right? It will be better make a YAG. Yeah, I fully agree with you.
And then calculate.
Also because you can have some minor movements of the IOL, of course. Yeah, absolutely. Before making and then making it. Yeah, absolutely. I fully agree with you.
Okay.
Can we go ahead?
Interesting. The future for me is customizing the IOL for every single patient. This system can customize IOL.
Yeah.
IOL.
Let me repeat. Let me show it again. This is what we will present at the SRS, Luigi. Actually, of course, this is based on the fact that you have a very accurate measure of the cornea. Okay. Now, if you have a very good biometry, of course, now phakic biometry, and if you know in advance what you want to do, if you want to put a spherical IOL or if you want to put a torical IOL, okay, and we can make several analyses on this to discuss it. But let's say that you, for example, in a case like this, you say to the software, look, I would like to put a torical IOL with such an index of refraction, okay? Then what the software does, make a scanning of all of the combination in between with a very accurate way between sphericity and toricity, make analysis of the point spread function, and look which one is the combination in between sphere, cylinder, and axis, which minimizes the point spread function. And this is the IOL that came out. Okay. No more question? Well, let's now move, Erasmo, can you come here? Let's move now to the CIPTA definition, because this will be important to know to have a clear idea on what the software does. Of course, any question, please interrupt me. We start with cTen. As you know, basically, we always strongly recommend a customized transepithelial approach. And let's start with the most common treatment, monofocal, mainly addressed to correct second-order aberration. And I will just tell now this based on ray tracing, but I will not repeat it because all of our plan in CIPTA Web are based on ray tracing. Okay, this will be something common for all of the plan. Now, you know that all of our treatment are customized. And you know that Precisio 2, the new tomographer, provides three main categories as output of the screening of analysis of the device. The first category of Precisio is NID, not irregular disorder. So you know that Precision make an analysis of the irregularity, the corneal morphological index. If you wish, then I will repeat again what is CMI. But if the irregularity is low, then the patient is classified as NID and automatically is addressed as basically mainly a second order treatment. Of course, you are free to change it whenever you want, but this is to automate all of the processes. So basically, when the patient is classified as NID, it go automatically in the plan as mainly second order correction. And which are the input data that we do require? Of course, the attempted correction, and optionally, you may introduce the biometric data. Remember, I told you that if we introduce the biometric data, we have like a warning, bam, 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 a control, because from one point of view, we will look at the best focusing distance considering your refraction, and from the other point of view, we have the total length. And if the difference will be higher than 0.3 millimeter, you know 0.3 millimeter is almost 1 diopter, a warning will bump out and will inform you if there is a discrepancy, and you may decide what to do, of course. How these monofocal phakic treatments are named in the CIPTA. They are named total corneal remodeling. Total corneal remodeling, basically, which one is the attempt if you select a TCR to correct the spherical correction, the attempted, the one that you introduced, of course for far vision, because this is a monofocal treatment, and same time also to correct the total corneal astigmatism. So basically what we are doing here, we are using your sphere and compensating the total corneal astigmatism. This is TCR, total corneal remodeling, meaning subjective sphere, corneal astigmatism, of course, including posterior contribution. As you know, Precision 2 now detects the epithelium in a very accurate way. So there are two options here. One, to still continue as we are doing right now, basically considering the epithelium as a standard thickness, and go ahead and make the customized transepithelial plan with the standard epithelium removal. And you will see an S, which stands for standard epithelium. So TCR with S on the top. This means that we are making a total corneal remodeling, considering the corneal astigmatism and considering the standard epithelium. But also, iRes 2 has the capability to consider the two ablation rates of epithelium and stroma, and only in iRes 2, there will be the possibility to customize, to introduce the ablation plan, having the epithelium now with the real shape detected by Precision 2. And this will be named as TCR-C for customizing. If in CIPTA you may say, look, my friend, if the posterior was not detected, or if the posterior for any reason is not reliable, then the software automatically will switch. It's very rare, but just to complete the information I have to tell you, then basically the software will shift to considering always the sphere But in such a case, if the posterior lacks or if the posterior is not reliable, then we will consider the anterior corneal astigmatism. And these will be classified not anymore as TCR, total, but only A, anterior corneal remodeling. Okay? And here there will be always standard epithelium and customized epithelium. The second option, fundamental option here is TSC. I want to make correction of the astigmatism of the spectacle. So, meaning there is an astigmatism of the lens and I want to take care of it on the cornea. So here it will be attempted spherical correction and attempted cylindrical correction. And this is the treatment classified as TSC. And once again, here you will have always standard and customized epithelium, and same will be for the anterior in case of lack of the posterior. Last, in case of completely lack of information also on the anterior shape, never happens, but this is also considered, then you have the standard ablation. Standard ablation means only taking care of basically ignoring the properties of the cornea. This basically covers the 80% of all of the cases, because we are speaking about the normal cases, and phakic. But in case we have basically a pseudo-phakic, now the input data, as you see from here, they change, because you don't need at all attempted refraction, because basically it's a known system. So here, the only data that needs to be introduced are the biometric data, the biometry, of course, the pseudo-phakic biometry, and the old data. And of course, here there will be just the total corneal remodeling, because of course we are taking care if the yaw historic, we are already taking care about it. And so we have the total, you see there is an A in front of it because we are taking care of the axial length. And again, here there will be still the customized epithelium or the standard epithelium. And in case of lack of the posterior, it will be exactly the same. Questions? Please.
In PCR, if my subjective astigmatism is different for the total corneal astigmatism, you compensate it in the sphere?
Yes, of course.
And I can see it on the program?
Of course. And you may say, for example, as we will see now in the settings, you may say, look, when I have a patient NID, please automatically plan for me both TCR and TSC, because I want to decide once I will see the plan. Okay? Any further question? All of these you can reply as it is for multifocal, meaning that in such a case, as we will see when we will play with the CIPTA, what we do, of course, you have to introduce here also the near correction, +2, +3, whatever you wish. And what the software will provide, always through ray tracing, is to define a bump. You will say to you will just tell to the software in the 2 central millimeters. Please do not focus at infinite distance, but focus at 30 centimeters. Okay, you introduce it, and then what the software will deliver a bump, of course, customized, and of course, always with a gradient that basically will take care of basically both far and near correction. For all of the rest is exactly the same. The structure is exactly the same. Okay? So you in the settings may say, I don't want to do it at all. Or you may say, please do it on the patient over 50 years. So basically, when Precisio will deliver the data to CIPTA Web, according with your setting, if you would have been said, for example, never do it, it will never make an mTCR, but will be always TCR. On the contrary, if you will tell to the software, please do it for all of patients over 50, it will automatically go like this. And of course, at the end of the day, you may always change. Of course, this is just the planning that will be automatically released on your laptop, okay? There are two important new applications which are fundamentally oriented to the correction of just the first order of aberration. So make, at the end of the day, a prism on the anterior shape of the cornea. And there are two main reasons for this. One, to induce an angle K, assuming that the retina is in a very good condition, because of course, if we make in a deliberate way an irregularity, if we make a decentration, the eye will tilt. And in a such case, if you want to correct, for example, for any reason, an angle K, assuming that the retina has a good answer, you automatically introduce how much in degree, of course, minor angle, because the prismatic takes a lot of tissue. And then automatically you will see an ablation, which will look like a decentration, which will induce such an angle K. And more the angle K, it is much more important, this application, and I would like whoever of you is interested, because this, I think, will be a quite revolutionary application in macular degeneration. So if, for example, we get from an OCT a good region where the retina is still safe, then we may say, please move the PSF from here to here, at the end inducing a prismatic angle, under the hypothesis that, considering that we are now addressing the point in a region where the sensitivity is good, we would expect that there will be not a tilting, the brain will not induce a tilting because we are addressing the points in the good region. So here, basically what we need for this application, we need you to introduce in micron the coordinates where we want to address the point, and you will see that we will make a prismatic angle exactly to compensate it. We will see an application later on after the break on this morning. Now let me tell you something more on, in the area where we show the best of our capabilities on the complex cases. So Precisio, the second family that Precisio deliver is what we call SID. Means that now we have an irregular cornea, but the finite element analysis that we do on Precisio inform us that the cornea is in a stable situation. So basically, we may remove tissue without to be worried to induce an ectasia. Irregular, but still robust, okay? Of course, in such a case, our main interest is to correct the high order aberration and the induced angle K due to the high order aberration. And here we have basically three main options. The first one, your input, you can make, it's irregular, but still you can do a good attempted correction. So you introduce your refraction. And in such a case, basically, what the software does, it will correct the high order aberration induced from any reason that caused it, the first order aberration related to the high order aberration, the sphere that you introduced, and of course the total corneal astigmatism. And again, customized epithelium or not customized epithelium. Okay, this is the first option. There are some cases where, you know, when, for example, the case that we will see this afternoon, it will be like this. There are cases where the attempted correction is very difficult. So now what we ask you, please introduce your biometric data. And so no attempted correction now. And the software, what we'll do, will make basically the total eye spherical correction under the assumption that the lens is basically according with the Gallstrand model, okay? Which basically depends from the total axial length. So we will correct the aberration according to the biometry, the spherical aberration, and the total corneal astigmatism. And again, always basically customizing the epithelium or not. Last but not least in importance, here we introduce basically for the pseudo-phakic, we introduce the biometric data and the YOL data. So again, no attempted correction. And in such a case, basically, again, we do delivery a correction of the high order astigmatism, the total eye in such a case, because we are considering also the contribution of the IOL, and the total eye cylinder correction. And this completes basically the scheme for the complex cases. So on the complex cases, if you introduce the attempted, and we are in the family of the phakic eyes, when you introduce the attempted correction, it automatically considers your sphere and the total corneal cylinder. If you introduce the biometric data, it will take basically the sphere according to the Gallstrand model and to the axial length and correct the total corneal astigmatism. If you introduce also the information of the IOL, it will automatically take care of all. In the phakic is just you know the data. You mean what we need? We need basically the an ACD. No, un po' di mettete un po' di luce, ragazzi. We need the ACD.
Yeah.
The lens thickness and the total axial length. Okay. The cornea thickness, we get it from Precision. Okay.
From
Precision. What we need at the end of the day, Vito, what we need to locate exactly in the space, where are the surfaces?
So the Precision can give you the lens thickness, the ACD. No. Who give you the ACD? Oh,
No.
you take
Precision takes basically the corneal thickness.
You consider how deep is, and
you will see it exactly. You will see today. You will see in case of a scar. You know, I mean, Paolo. In case of a scar, the most relevant point is that the ablation rate, it's not only very homogeneous. So generally, in case of a scar, we combine at the end of the treatment a PTK with a fluid mask, not because basically the ablation was not customized, because the ablation is still always customized, but only to remove eventually minor irregularities due to basically the difference in ablation rate. But I'm just discussing of a few microns. Regarding the thickness, you go down. Ideally, you would like always to go below basically the scar. but this will depend, of course, from. However, according with our experience, you will see several cases. You will have, however, a large benefit in making the remodeling of the cornea, even if you cannot remove completely the scar. Any further question?
Regularity, not this kind.
Absolutely. Fully agree with you.
Which curvature had your anterior surface under removing, depending on how deep is your remodeling?
Perfect, but this will be deducted. The shape that we will provide will be always the consequence of the ray tracing. So at the end of the day, generally speaking, the scar does never compromise our capability to detect the shape, okay? And as a consequence, we may always define the ideal shape. It may be, as we told just a few seconds before, that after the ablation, the surface will not be completely smooth. You will see that for several reasons, iRes is a very tiny and smooth ablation. You will see the quality of the ablation in the afternoon. But again, due to the reason that sometimes the ablation rate may differ in a local point due to the scar, in some cases, it will be better to make a PTK with a fluid mask at the end.
The chance to do an intraoperative checking of the.
We are working, actually, iRes 2 will be delivered as it is right now with basically in the configuration, including the cross-linking. But the cross-linking, you see there, it's activated with what we call a moving arm inside. And this moving arm is two basically places, let's say two possibilities. But this is still in a research stage. We are working to introduce in the second arm basically, let's say, a precision to make real time, basically. And this will be exactly to control the ablation rate in such a cases. But this will come in a couple of years, not now.
Thank you.
Finally, the last family, the ectatic, okay? In the ectatic, we have the need to combine together with the corneal remodeling. Absolutely, we need to combine the cross-linking. So the ectatic is the same structure of the table. The only difference is that the software, knowing that it is an ectatic, it will automatically add a cross-linking plan. And the cross-linking plan may be a standard cross-linking, you know, centered in the center of the pupil, 9 millimeter, blah, 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 blah. But in iRes 2, there will be the option to customize basically not only, you know, overall, let me tell you in a better way, to customize also the irradiation. So to minimize the irradiation, delivering less energy in the periphery and higher energy where the gradient of the pachymetry is worse. You know, all of you, you know better than me that you can even have a cornea of 300 micron thickness in a stable situation. So it's not just the thickness that we need to look, but what we need to look is how the gradient of the thickness changes. The higher the gradient, the worse basically the elasticity module of the cornea. So what we will see later on in the example is that there is the option to customize the cross-linking, but including a gradient. Potete alzare le luci per favore che è troppo buio? So, this, of course, will be available only in iRes 2. just short info. Of course, basically CIPTA 2 allow either PRK and LASIK, but for the reason that I told you before, only the PRK and LASIK will not be available on SID and AD, on the complex cases, because, however, for the reason I told you, I mean, it will be a disaster. And for PRK, there is an option, and this option basically, of course, is more a theoretical option, but you know that you may, on theory, basically remove mechanically the epithelium, and assuming that you may do the refraction of the patient without the epithelium, then basically you may introduce the attempted correction, not on the anterior shape, but after removing the epithelium to take care of the irregularity of the epithelium. But this is just a possibility that, you know, it's over there, but it will be very, you know better than me that it's not at all easy to make a refraction in lack of the epithelium. And of course, the structure is always, you can do the monofocal, you can do the multifocal, and you can do also the first order aberration. Again, you cannot do basically, nor in PRK and nor in LASIK, there is no possibility to do basically the complex cases. Well, it was, you know, an introduction on all of the possibility of CIPTA. Any question, please.
Ti volevo chiedere, Giuseppe, in quest'ultimo aspetto, cioè sulle corna ectasiche, tu questo trattamento customizzato, cioè nel senso tale di trattare con il cross-linking con maggiore energia, lo fai avendo già con l'epitelio presente, quindi nel senso che è un cross-linking transepiteliale, oppure togli l'epitelio? Uno. Seconda domanda è rispetto a ectasia appunto che tu già hai accennato, volevo un po' per post-LASIK, poi ci sono dei margini di trattamento di poter fare questo tipo di qualcosa per poterle cercare di fermare rispetto al cross-linking classico? Grazie.
Allora, per quanto concerne la prima domanda, siccome comunque noi rimodelliamo la superficie della cornea e comunque per rimodellarla dobbiamo ablare del tessuto, la risposta alla prima tua domanda è che comunque il cross-linking è sempre un EPO. La customizzazione, noi attualmente utilizziamo una soluzione di riboflavina molto particolare che è stata studiata proprio per questo trattamento combinato, se ne parlerà Cosimo Mazzotta poi nel pomeriggio anche di questo, che ci consente di ridurre l'erogazione a soli 3 minuti e quindi diciamo dal punto di vista proprio di danno derivante dagli UV è molto ridotto. Per quanto riguarda invece la ulteriore riduzione degli UV, di cui parlavo appunto prima, questa è una novità che sarà collegata all'introduzione di iRes 2. Per quanto riguarda la seconda domanda, scusa, mi ripeti la... Ok, per quanto riguarda il trattamento, come ti dicevo, il preciso è in grado comunque di rilevare l'ectasia. Lui non sa se è un'ectasia, voglio dire, esattamente. Però lui comunque te la rileva e assolutamente ti corregge con CIPTA le irregolarità conseguenti. Quindi a prescindere questo da quale sia la causa. Tieni presente che noi abbiamo validato la nostra riboflavina al livello di danno dell'endotelio con prove di laboratorio fino a 300 micron. Quindi noi sappiamo che fino a 300 micron di residuo di tessuto non abbiamo danno praticamente a livello dell'endotelio. Altre domande? Bene, io adesso ci sono adesso delle sezioni un po' più pratiche Io direi, Erasmo, andiamo un attimo sui settings. Ora, voi vedete, posso averlo pure io sulla schermata mia, qui così andiamo insieme. Ora, quello che voi vedete qui davanti è la schermata principale d'accesso. E in alto a destra vediamo, me la puoi mettere... Ah, yeah, oh, excuse me. Okay. Excuse me. So what you see here is basically, you know, the dashboard okay, of the CIPTA Web, and on top right you have the information of your name. In such a case, Rosalina Mastronardi here is the doctor. And now we enter in the section of Rosalina and see what you can do in such a section. So first of all, your user details. And here there is not too much to say, all of your information, okay? And let's be focused to the most important points. Let's look for, first of all, here again, before entering in this, remember, whatever you introduce here, it will be used to plan the surgery, okay? And will automatically plan, the surgery will be automatically planned according to what you selected is basically your preferred choice. So let's go, for example, in the global setting. Global will be relative to all of the plans. In the global settings, first of all, you say to your device, would I like to use also not validated surfaces to plan the customized ablation? Well, our suggestion is always to use validated surfaces because, you know, what Preciso does, automatically take to acquisition, and only if the difference between the two surfaces are within predefined range, it allows to export it. So at the end of the day, you may, of course, reduce this basically requirement. You may say, for example, I would like also to plan a customized ablation if the surfaces are not validated. But we do suggest you, I mean, it's now very rare that Preciso is not able to take a repeatable map. So I would like to suggest you to keep as it is. Then you may say for the near vision, never, so no matter. Again, please remember that if you say never here, it does not mean that in the real time you cannot change. You can always change. But here basically is the default, okay? On you may say, for example, over 45, over 50. This means that if a patient will be 46 and it will be planned not as TCR, but it will be MTCR, multifocal, okay? Then there are warning limits. Another very important feature you have to know in CIPTA, whoever of you is familiar, you know that once basically you introduce your refractive zone, which came from P-metric, or if you decide to change it, it automatically will calculate the ablation. And after calculating the ablation, if there is a warning, then basically you have to go back and reduce the zone if you want to basically eliminate the warning. Now what the software does, as you will see, it automatically basically reduces the zone to stay within the limits. And now we come to the limits. Which are the limits? Well, the limits are defined according to basically the categories, which means for each kind of category, you may say for this treatment, I don't want to remove more than this or more than that. Again, we calculated such limits. Let's show the limits here. The limits are referred to basically max volume of ablation, max depth of ablation, and how these limits are defined. So we do recommend you to not change these limits because these are basically calculated through a finite element analysis. But of course, if you want to change the warning limits, you may change it. The limit that you cannot change are the safety limits. Those are basically limits that we are sure that through the finite element analysis, there will be problems. So those limits basically cannot be changed. Of course, if you want, however, to do surgery, even if you have a safety limit on, you can still do it. But I mean, does not make any sense to change this limit because these are very defined in a very accurate way. You have, if you overcome the warning limits, you have a warning, and it will tell which one is the warning. If you go over the safety, you will have a cross, a red cross, which will tell you you are overcoming the safety limit, but still it's your choice. At the end of the day, it's always your choice. Right, absolutely. That's always choice of the surgeon. Any question? The finite element analysis.
Yeah, sure. But you need to take a look to the literature data to keep the limit. Not exceed the ablation. It's not limited to finite element analysis. This is a prognostic factor, but we need to take a look to the literature data to know, and this is a work in progress also, to know exactly when it's to stop.
I fully agree with you, Cosimo, and that's the reason you can change it, warning limits. But at the end of the day, as you know, always looking at literature, literature is not homogeneous. You have, of course, several different opinions. And of course, I mean, due to the reason that our numbers are calculated according, a model, the finite element analysis. But for each one category, you have different limits, of course. Okay.
And the limit can be related also to the kind of laser you use.
Those are for, of course, our system.
Yeah, this is only for our system.
Absolutely, absolutely. This is, however, in terms of finite element analysis, those numbers, then let me also be more accurate in my answer. Luigi, that when you make standard ablation, different laser has different algorithms. And from this point of view, the effective amount of tissue removed, it really depends from the laser. And for this reason, I agree with you. For us, we make intersection between surfaces, so it's not an algorithm. It's whatever it. So for us, if we say we remove 50 micron, we really remove 50 micron. So that's the reason why. And so this is to tell you that on theory, if basically all of the system would have been using the same way to calculate the ablation, then the limit should be the same for all. But that's, of course, that's not the reality. So now let's look at the specific settings for each plan. Let's look before the NID, the most common. Now, for example, Rosalina Mastronardi selected that, look, for whichever eye will came out NID, not irregular disorder, I want you to plan for me automatically these two types of treatment, total corneal remodeling and total subjective correction. This means that we will see that the result of the CIPTA Web planned we will have two ablations, which will be presented at the same time. One correcting sphere, attempted sphere, and total corneal astigmatism. And the second one correcting attempted sphere and attempted cylinder. And as you will see, you can compare and finally select which one you want to export to the laser. Let's see, for example, the first one. So what you have to tell to the software here, and you know that when we plan the ablation, we have to decide what we want to do for the refractive zone, where basically we do the ray tracing. And for the connecting zone, you know, we make a very smoothing connection to grant an homogeneous reepithelialization. So let's look at the refractive zone. First of all, which basically photopic pupil to use in order to define basically the best focusing point. The photopic you may, now it's came from p-matrix, because if we use p-matrix, it automatically will introduce it. But you may say, I want to always use, for example, 2 millimeter. And then in such a case, it will use this. Why it's important, the photopic? Because in photopic, we define the best focusing distance, which is the point from where we will do the ray tracing, okay? So p-matrix again. And in the ideal pupil basically allow us to define the limit of the refractive zone. And you say, here you see, look, p-matrix, but automatically auto-limited by the warning limits. What does it mean? That if basically the software will find that any of the limits is overcome, it automatically will reduce the refractive zone until the limit will be satisfied. So you have not to waste any time. It will be automatically executed by the software. Okay? Then you say p-matrix, or you say predefine the refractive zone, and then it will take whatever you wish. Okay. Second point, it's related to basically photopic, ideal pupil, the maximum refractive zone. Okay. No, I mean the minimum refractive zone. You may say, of course, my friend, you may reduce it, right? Because you say, for example, it's important for the warning, but I don't want to go below a value, okay? Because, you know, it may reduce. And then you may say, look, you may reduce it, but not below 5 millimeters, for example, okay? And then it will stop with whatever you, okay? This will even more answer to your question, okay, Giulio? Finally, you may also say, well, up my focusing distance, it's infinite, or I mean 5 meters. You can even input, for example, 5 meters if you want not to have a distance, like when you look at the chart at the end of the day. Of course, here we suggest you to keep to infinite, but not to change it. And again, basically the surgical technique, cTen or LASIK, and when you do cTen, you may say standard epithelium or customized epithelium, okay? And then finally, the epithelium debridement, you may say just up to the end of the refractive, of the connecting zone, or automatically, for example, if we do a cross-linking, you can put it up to basically 9 millimeter or whichever. You may do circular and up to the limits that you wish. Andiamo avanti. Let's go on. Ah, good. Very good. So, first of all, in the connecting zone, you may say no extrapolation. So if the tomographic data, they do not overcome, for example, in one region, 8 or 9 millimeter, it will stop to such a value. And we strongly recommend to keep it. Now, which one? This is a very important new in CIPTA Web. So whoever of you up to now used CIPTA 1, you know that we have basically a limit of maximum diopter, which by default is 125 for the normal, is lower for the complex. Now the software make a much more complex calculation because it look at the gradient in power between the refractive zone and the zone not treated. And now the software calculate the width to avoid, to overcome 25 diopter per millimeter. So this basically, if I have to give you a comparison with the old CIPTA, 25 per millimeter will be an equivalent of something in between 80 and 100, okay? So it will be a very smooth connection. The additional offset is exactly like CIPTA 1. You have to dedicate some room for your transition. And in such a case, the limit will be the 50 micron. And also the dioptrical range, this is how much, this is a further limit, but we say, look, I don't want in the connecting zone that the power will go over 25. So basically, this means that if you consider, for example, Giulio, I see that you are looking very well. If you consider that, for example, at the edge you have around 50, this means that you will never go over 75. Okay, it's a further control. So all of these basically are the limits that are considered in the planning of the ablation. Okay. I would like, for the stable irregular disorder, we strongly recommend you to avoid any different plan. It will automatically, in such a case, plan the corneal remodeling. And if you introduce the biometric data, it automatically will switch considering it. So you have not to be worried. Whatever data you will add, it will automatically plan the ablation according with your choice. And we will see it in the medical record. Finally, for the cross-linking, on the standard cross-linking, you may say plan both standard and custom. On the standard cross-linking, you define the diameter of the cross-linking, which one is the fluence that you want to use, which one is the power that you want to use, which one the mode, if continuous or pulsed, and which are the warning limits. So I don't want to do cross-linking below these. I don't want to do cross-linking above these in thickness, okay? For the customized, and then we stop to take a break, but for the customized, you basically define which one is the minimum energy and which one is the maximum energy to be irradiated. And the software, according how much is the gradient of the stroma, will provide the minimum at the edge and the maximum at the thinnest point of the cornea. Questions? Well, let's take a break. So let's start again. CIPTA Web is I told you beginning, it's not only basically a tool for planning, but is also a tool for having a global control and overview of the entire process. So CIPTA Web will allow you to take control of precision, of iRes, but also another important function of CIPTA Web is to allow you to use it as basically an electronic medical record. And now Erasmo will show you how to first use to how to register, but overall how to use the medical record and the data that you can input in the medical record.
Okay. Hi to everyone. So to register to our web platform, first of all, the medical center must reach an agreement with iVis technology. After that, doctor that want to have an access to our platform must provide us a web account, web email that we will use to start registration process. After the doctor gives us this email, we will activate the account CIPTA Web, and the doctor will receive on email address that gives us an activation mail where he can set the password that he will use to log into the web system. So after activation, this is the platform ready to use, and as Mr. Dippolito was saying, this platform give us the possibility to introduce also medical record information. So this is the view of a center, the iVis center. So we can see a list of patients with last name and first name, and we see that there are these little labels that show us where the patient is in the 4D process, because the patient can be in diagnostic process, in design process where the CIPTA plan is calculated, in the delivery process where plan iRes is executed. To introduce before precise acquisition, we can introduce the medical record. So information, for example, of an ocular visit of the patient. So in this data, the doctor can introduce, for example, the diagnosis of the patient, some refractive data, and all the data that we can introduce will be automatically sent to Precision. So this data can be inserted on web platform and also on Precision. And after we insert this data on Precision, they will be sent the web platform, and at the same time, if we insert this data on web platform, we will have this data available also on Precision physical device. Data that we can introduce are surgeon diagnosis, CT wear, corrected and uncorrected vision, psychological data, and as Mr. Dippolito was saying before, there are the possibility to introduce biometric data that will be used for a particular treatment. And also, if we have a pseudo-phakic eye, we can introduce also IOL data. Some other information can be if we have an opacity on the eye, or for example, intraocular pressure of the eye. If we are some record, some history for this patient, for example, a previous LASIK, we can introduce to take all the information together, and also we can attach some file as for example, a biometric exam or some other exam that you think are useful for patient diagnosis. And another feature is that we can see also where update on data is made, where the update was made, so on Precision physical device or on CIPTA Web website, and also what data are updated every time there is a change in the data.
So at the end of the day, it's a true electronic medical record that you can basically access wherever you are. If there is no specific question about the medical record, now we will look at some specific plan in order to give you basically a better understanding of all of the plan of ablation. Io mi metto di qua. So Erasmo, please let's look at an NAD patient. You see the label here. Now okay, just stop for a moment. Okay, let's start with a TCR, and let's look the precision. So here you see for this patient, for example, it's like entering in precision, but we are accessing in precision from the web. So, and in the afternoon, we'll make a complete, wet lab on this. But what we see here for this patient, for example, is that we see the elevation map for this patient, and we see that the classification of the patient is NAD. Okay. Non si vede. However, on the top right, we see that the patient is NAD, so it's a normal eye. And ST stay for repeatability, which is achieved total, which means for all of the surfaces of the cornea. Okay. We see the three surfaces. And let's look at the pachymetry of this guy. The total pachymetry, epithelial. We see that the epithelial is, for this patient, is thin, but overall quite homogeneous. And if we see the refractive power of the epithelium, we see that it's very regular, as you see, okay? And it's in the range of -0.4, -0.5. Now let's look at the ray tracing power for this patient. You see that, again, if we go on the anterior shape, this patient is in the range of 34. If we would have been looking at the axial map for this patient, we see that the axial map of this patient is in the range of 44, 45. Now, two more maps that we have in Precision are the map related to the quality of vision. And on more detail, we see that the total wavefront here is quite regular for this patient. This is, again, it's an NAD patient. The point spread function, which again represents where the old ray they will converge, and in such a case, the view cross is the centroid of the point spread function. You see it's very close to the center of the map. Again, this patient has no relevant angle K induced. Now, let's see which are the plans that were automatically planned for this patient. You see, this patient was is an NAD, And automatically now, in the setting, we decided that the patient, we would have been looking for two plans: total corneal remodeling and total subjective correction. And what we may ask to the software is, which are the difference in the ablation between the two plans? And so we can go in difference. And see, oh, in such a case, there was a quite good compliance in between the two ablation, okay? And in fact, if we look at the refraction, go back, in the patient in the TCR, the treatment, go back in sphere, let's, no, go back in the spherical correction. Showed which one the sphere, okay. You see the sphere was 362 with a cylinder of 0.76 negative. This is the total corneal astigmatism at 5. In the TSC, the ablation was minus 375, minus 0.5 at 35. So basically, quite close ablation. And now if we look at, let's go to TCR again. Let's say that, for example, now, very minor difference, so we decide to go for the total corneal remodeling. If we go now to look at the expected post-op maps, go in elevation. We see that the post-op elevation is regular, but in such a case, the posterior is also quite regular. But let's go now to the refractive post-op, expected ray tracing. If we see the expected ray tracing, you see the anterior has a slight astigmatism, which is compensated by the posterior. So if we go on total cornea is now, as you see, very regular. But in such a case, I mean, was a regular patient. So it was really a minor difference in between these two. Okay. So this was a very normal case. Let's now move to a case in which we basically a pseudo-phakic patient, but still regular patient. If we now go in the medical record for this patient, you see the biometric data. Let's look at the biometric data. Here we have the cornea information, thickness, anterior chamber depth, lens thickness of the eye. And look, this eye is a very long eye, all over 29. The implanted IOL was 10 diopter, and basically almost no cylinder, and the refractive index was 147 bisymmetrical. So in such a case, now we don't need refraction, right? Because all of the data are known. And let's see what software did here. Here now, this is the plan of the ablation. And let's look at which one was the correction that was executed. Let's say the corresponding, the ablation which correspond to such ablation plan. Okay, so now what you can do is, well, let's see, but this patient is really improving his vision with -2, -125 at 166. Okay, so this is a very important tool, you understand. Now, in a patient like this is a very regular patient, so I do expect that this will be really the refraction that you will find for the patient. But this is extremely helpful when we deal, of course, with complex cornea, because in such a case, you know better than me that the reliability of the refraction is much lower. So look at how powerful is the tool. Basically, we can define the ablation, which is now basically, I mean, not that. The only doubt that we may have is on the reliability of the biometry. That's an important point that we should consider, because basically, according to the reliability of the biometry, then we know the exact position of the IOL. But if we now basically look here, the post-op maps and go in expected ray tracing, look, the astigmatism on the anterior, and if we go on the total cornea, again, you see the compensation. A more interesting case will be what we will see later on when we do implant a toric IOL, because we will see that on the total cornea, we have a toricity, which basically is then compensated on the total eye, because basically the lens will compensate for it. So now let's move to a more complex case. Let's take an SID. Let's look at the medical record for this SID. See if, let's say, the refractive data. So this patient was +2 -4.5 decilinder, and the biometric data were introduced here, as you see. This is a phakic patient, so no IOL. So let's look what the software did here. First of all, let's look now before the ablation. Let's see how strange is this patient. Let's go in Precisio. Nice, right? This is a very relevant irregular astigmatism, but it's not an ectasia. And you see it's defined, again, full repeatability, but it's stable. And in fact, if we look at the thickness map, we see that there is a good thickness. And if this would have been an ectasia, would have been having a minimum here, which is not here. That's the reason why this is classified as SID, okay? But the epithelium, again, here is quite good thinner, and you see it's homogeneous. Another sign, if this would have been an ectasia, here it would have been much more thinner. So this is, again, it's a stable, irregular astigmatism. And if we look at the ray tracing, pre-op, you see it's a very pronounced astigmatism, which again, the posterior basically somewhat compensates the anterior, okay? The quality of vision of this patient, it will not be like the one that we saw before. Let's see. Look, very, of course, we see the astigmatism, but what we have to notice here is also that the point, look at the tilting here. You see the point spread function. These are, now, this red dot basically emphasize what? That there is a big dispersion of the point, a very large point spread function. So this means that, of course, the quality of vision of this patient is compromised, but also, you see, while in the previous case, though the cross was almost, the cross represents the axis of the central axis of the system, while the blue is the centroid of all of the refracted point through the ray tracing. So this means that this patient is a vertical tilting, okay? And in terms of quality of vision, we see that the quality of vision is very poor. Now let's look at the plan for this patient. Well, here we see that basically the treatment is very, very narrow. And you will see that in all of the complex cases, especially, of course, when we are in the presence of ectasia, generally the treatment is really in a very narrow refractive zone. All of you are familiar with the Style-Crawford effect. Those guys in 1930, they discovered that the percentage of photons that really contribute to the refraction are 80% in the 1-2 central millimeters. And what is very important in such a case basically is, yes, of course, when we are dealing with a so complex case, to limit the refractive zone, but grant a very smooth connecting zone to avoid glare and halos. So here, basically, you see that despite the refractive zone is only 1 millimeter, look at, we go up to 7.6 in the connecting zone. So this means creating a very smooth connecting zone. And the refractive zone was automatically reduced in order to grant such a gradient, okay? This is the gradient, the 25 diopter I was discussing you before. And if we look at the post-op maps here, okay, here now we see the post-op of this guy. We see that in the central, it's much more regular, but let's look really the refractive, the ray tracing refractive. Look, here we are, of course, our target is this one now, okay? We are regularizing here. You see that there is still the astigmatic compound here, which, of course, in the total cornea disappear. And again, if we look at basically now, look, this is the ablation based, remember, we introduced either the spectacle refraction, but also we introduced the biometric data. So we can make the comparison in between the two ablations. So in this case, the corrected sphere is basically based on the subjective sphere. And let's look at which one was the correction. Go in the refraction. Here you see it was 281 with a cylinder of minus 6.1, okay? While if we go and see the data on ATCR, so based on the biometric data, we see that in such a case, the ablation of the sphere was minus 2 with plus 0.56. And again, we can make the comparison between the two ablations. And again, one case where the refraction was exactly, this is a further confirmation in a case like this, that the refraction was exactly matching basically the biometric data. On the contrary, and this is especially on the cone, generally on the cone, the sphere refraction is underestimated, and you may clearly see it. So finally, again, here, two plans were generated automatically, because basically you, surgeon, you introduced either the subjective refraction and the biometric data. And you can make the choice at the end of the day on which one you want to execute. If only the biometric data would have been introduced, or only the refraction, would have been having just one plan. Okay? Any question?
Yeah, that's
No, it's
very
not.
much like
This was a transplantation.
Oh yeah, post-transplant.
Yeah,
Yeah.
but it was not because you see again. Go back. The thickness is almost it's okay, and the epithelium is okay. This was in reality. This was at least this was in right, but in the yeah, right, yeah. Absolutely, I fully agree with you. But yeah,
Because surgery for the pellucid is not so good.
absolutely. But if you go back again in Precisio Pre-op, look Cosimo, if we go in the pachymetry here, in this case, you see epithelium it's not thinner, it should be like homogeneous. And also the minimum pachymetry is almost central, so not peripheral. And however, the surgeon who sent us this patient told us it was a transplantation. Any further question on this patient? So now let's move on some ectatic patient. Of this, the results will be, you will get some results later on. I mean, right. I will let you to speak about quality of vision. Okay, so there will be a couple of presentation in the early afternoon that they will tell you, and I suppose also that the two surgeries that we will see later on today, they already got the first eye. So we will ask to the patient, how is your quality of vision? Okay. Okay. So we will have later on one guy who, where is Pino? One guy that had 71-year-old, right? That he has a corneal dystrophy, right? Okay, and
of epithelium, and the epithelium was thicker than normal. It was the 100 micron, just the epithelium.
oh. So this guy, we will have in the afternoon the second eye surgery, and we will ask him, how do you see? But also Cosimo, we did several eyes with a very narrow refractive zone. Cosimo will have also a presentation in the afternoon. So now let me just give you overall an introduction. The afternoon will be dedicated to the real, basically, quality of vision of those patients. What I want to give you right now is just to show you how you can play with software. Okay, this is the target of this presentation. So look at this very strange now ectasia. This is very, very strange. Okay, this is classified now ectasia, but look where it's very, very particular. You see, but now if you see the pachymetry here, look where basically we have the thinness point. Okay, and let's see also the ray tracing for this guy. Let's look at the medical record here before. Okay, refractive -5, -3, biometric data. How much is it? 28, right? Okay. So let's see now what basically. Let's go to Precisio again. Let's now look to the ray tracing refractive maps. Look now, of course, this is a very strong irregular astigmatic, but look how the total cornea, how is smoother than the anterior, okay? And let's look now the plan. Again, two plans. I remember you, there was either the refractive and the biometric data. Now we are looking the refractive. Which one was the correction here? The correspondent correction to this ablation. -4, -5 at 19. And let's look the ray tracing post-op maps. Well, here now it's much more evident the astigmatism on the anterior. And if we go on the total cornea, we see that we are targeting to reach almost 20, 27, I can say, okay, 27, 28, okay. This is the target that we have with the ETCR. Let's go to the ATCR with the biometric data. Again, the astigmatism. No, let's here the target in refraction. Let's see the target here. You see here now we are targeting -5, okay, and we see now the difference in the ablation between the two plans. We see that one is more hyperopic than the other. You see. Because basically, not too much, but here there is a difference, okay? While the one before, they were almost identical, now we see a difference. And in refractive target, we may see where we will go, we will end up in refraction. So if we see in now ETCR, in total cornea, you can see, because here I can say 26. So this is flattened more one diopter than the other one. Of course, in a case like this, you know, I mean, it's, you know, we are playing with minor relevant tools, but there are cases where the difference may even be larger. And, you know, another important point that you can do is, especially when are those complex cases, you may also compare the worse eye with the better eye and look at basically, you know, the other eye and see which one is the target on the other eye, where you may trust eventually your refraction, and understand which one of the two is more close to the reality. I will tell you, up to now, we have an experience of roughly 300-400 cases, which already did. And I would say that in 70 to 80% of the cases, we went with the biometric data, okay? Okay, so this is, let's look now at the last case. Ectatic, this is an ectatic with basically pseudo-phakic. Quite relevant astigmatism. Let's look at the pachymetry of this guy. You see much thinner here. Also the epithelium is thinner here. Let's look at this epithelium from a refractive point of view. You see, look at the chromatic compensation of the epithelium, how relevant is here. From a negative of -1.5 to a positive of 1.5. So we have a difference of more than 2.5 diopter between the inferior temporal and superior nasal. Yeah. And ray tracing. look the total cornea, how gone total, always how it compensates, okay? And now let's go and let's look at the pre-op quality of vision here. Look always how basically always the focusing, the centroid of the best focusing point is always moved towards the bump, always, okay? So it means that the brain rotates the eye to compensate for it. And of course, the quality of vision is tilted and deformed here, okay? Now, let's basically look at the here on the, let's look at the ablation. Here, as you will see, the ablation is basically of a sphere of minus 3.5, minus 2. There is only, only now the ablation based on the biometry, because basically here we have all of the data. And let's look now the refractive post-op. Look, the anterior, remember the refractive pre-op. Now the refractive post-op is still astigmatic, but still irregular, as you see. But if we go on total cornea, the astigmatism became now regular, but still relevant, which is compensated. Remember, the IOL was an astigmatic IOL. And now, basically, on the total eye, of course, the total eye compensate. So this is the confirmation that on the anterior cornea, we took care of the contribution of the posterior, but also of the IOL, okay? And last here, also in terms of quality of vision, in such a, let's look at the refractive zone. How much was here? Let's see. So here, the refractive zone was reduced to 3.2, okay? And you see all of the parameters were satisfied in such a case. So it was not necessary to go below 3.2, okay? And I would say that, yeah, there is another one last case that I want to show you, an FR, an angle K for macula degeneration. So let's look at the eye. So the eye, you see, is it's classified as an NAD because there are not irregular. Basically, the cornea is somewhat astigmatic, but no relevant irregularities. And let's go in edit and let's see which were the parameters that were introduced in the ablation. Okay, here you see that the target was to provide an offset of 100 micron in X and 50 micron in Y. So this was the 100, the offset, the PSF of 100 in X and 50 in Y. Now let's go and see the ablation. You see, the ablation is clearly show a decentration in the ablation because we want to introduce a tilting in such an eye. Okay. And if we look at the post-op, let's look the elevation before. We see that, of course, we created basically an irregularity on the because we are inducing a prism. But which one is our target? We see it in the quality of vision. You see here, look, we moved the PSF 150, you see? So basically here our target is to move the centroid of the PSF exactly in the portion of the retina that was our interest, because we were from the OCT considering that this was the best region where to address basically our centroid. Any question? Absolutely. This will require, of course, basically clinical trial. Absolutely.
Do you have any idea about the results so far of the patients that are treated?
No patient treated.
Oh yeah, okay. It's a simulation of.
This is just a brand new. Okay. It's a brand new application. And of course, this is addressed to patients that basically have a relevant degeneration. Okay. Assolutamente sì. Allora, noi possiamo questa applicazione, I will then translate in English, okay? So basically the question was how we define such a point, and he was suggesting to use microperimetry, which of course I fully agree with you. But on top of this, after you define, dopo che tu hai definito l'area, tu praticamente vai a individuare qual è la porzione, no? Qual è il punto, diciamo meglio ancora, dove tu vorresti idealmente focalizzare. Quindi quanto ti vuoi spostare dalla fovea, in buona sostanza, no? Il riferimento tuo è la fovea. E tu gli dici, voglio rispetto alla fovea un offset di 100 micron, e noi poi determiniamo qual è l'angolo che è necessario per avere quei 100 micron, sempre tramite il ray tracing. Questa applicazione ha due grandi possibilità. O tu prevedi che il cervello del paziente reagisce e allora tu stai introducendo un prisma per ruotare l'occhio, tipo per compensare uno strabismo, ma in questo caso la retina reagisce e quindi induci un prisma e l'occhio ruota proprio perché hai indotto un prisma, un po' come nel keratocono, no? Nel keratocono tu che c'hai? Hai visto come si sposta? Perché si sposta nel keratocono? Perché tu c'hai un bump e quindi il cervello ruota l'occhio, ok? Perché la retina è sana. Ma nel caso in cui tu invece hai una retina degenerata, è come dire che tu gli stai indirizzando i raggi nel punto dove può vedere bene, e siccome di là vede bene, in teoria, che è tutto poi da dimostrare con dei clinical trial, lui non girerà l'occhio perché gli sta indirizzando dove vede bene.
Questi fanno il biofeedback. Prima di mettere il prisma, perché noi applicano, fanno il biofeedback, stimolante e poi diamo il prisma.
Okay.
Potrebbe essere un'alternativa al...
Certo. Assolutamente, certo. È un'alternativa al prisma, certo, assolutamente. Ma questo è il prisma, solo che non lo è un prisma che tu stai facendo sulla cosa. È molto più accurato, ovviamente, no? That's a very good question. The only thing that I can... Absolutely. What I want to tell you is that the higher the distance that you want to have from the foea, the higher the ablation. Prismatic ablation are very tissue consumption. So again, here it will help very much the automatic reduction of the refractive zone. Look here, we'll go in the ablation again. In a case like this, you see the refractive zone was not very, was 4.2, and the smoothing, look, this is all smoothing here, because you want to create the prism, but then you don't want to have regression, of course. And for this reason, you have to have a very large smoothing zone. So to answer to your question, Paolo, at the end of the day, if the higher basically the distance, the lower the refractive zone in order basically to grant stability. to give you an idea according, in order to grant stability, I don't think that we can go over 500 micron of offset, half a millimeter. Okay, but 500 micron, it's quite relevant. Okay.
Could you test that with prisms before you do the surgery?
This was exactly what you were saying. This was exactly that's exactly. And of course, you understand that if with the prism the patient improves, with this will improve much more, because I mean, the prism is something that you put over there and the eye move. In such a case, you are just remodeling the cornea. So I'm sure. Well, I am not sure about the concept, but because basically we are still thinking that the brain will not change the angle. Okay, but if with the prism it works well, for sure with this will work better by definition.
Similar question. It would be very helpful if we knew, this is the correction, the prismatic correction, if we knew to what prism this corresponds, which prism strength to put on.
Of course, yes.
For simulation.
Yeah.
It does not say it here, right?
Oh, let me see. We can, if not, we can easily add. I mean, that's cool. We will. Okay. Vuoi prendere nota di questo documento? Yeah, of course. We can. Well, this will be that's a good idea. So what we will do here, we will provide the angle that we calculate. You can see tests on the patient, and if it works, then you can do it. Yeah, that's good. Thanks. This is the very good to having this kind of meeting. Is very important to exchange ideas. Any further question? Do you want to play with software? We want to make an ablation. Okay. So now let's say that, for example, let's say, la sfericità post-op, certo, assolutamente.
Di ogni variabile il parametro per intendersi quanto pesa in percentuale sull'ablazione che stiamo andando a fare. Perché chiaramente questo è un software, dietro al software ci sono delle formule matematiche sicuramente. E quella è una cosa che vi chiedo già da un po'.
Ok. Let me translate because your question. He's asking which one is the weight of the lens in the ray tracing process. Ok. Allora, Pasqua, prima di tutto diciamo una cosa, che non ci sono algoritmi strani, è solo un processo di ray tracing, un vero e proprio processo di ray tracing, quindi non ci sono numerini strani che aggiungiamo, noi seguiamo solo il percorso dell'occhio. Quanto pesa? Stamattina, puoi tornare un attimo sulla presentazione di stamattina sul ray tracing, per favore? Vado io di qua? Allora, tu sai meglio di me che quando metti una IOL un valore medio è intorno alle 20 diottrie, no? Il peso però reale della lente che vai a mettere nel ray tracing non è ovviamente 20, perché chiaramente è molto più vicino alla retina rispetto alla cornea. Quindi il peso reale, se tu lo vai a vedere, vai in total. Ok, la cornea, fermati un attimo sulla cornea, il peso totale della cornea è intorno alle 30-31 diottrie di reale refrattivo. Se andiamo a considerare il cristallino, ok? Col cristallino arriviamo in totale alle famose 40-41 diottrie, che poi corrisponde, facendo l'inverso, a una lunghezza media di 23 mm, ok? Quindi il peso del cristallino, naturale o artificiale che sia, è intorno alle 10 diottrie. Chiaramente più la lente è spostata indietro, e quindi qui poi conta anche la CD della cristallina, no? Più è indietro e più si riduce il peso. Più la camera è bassa e più aumenta il peso. Ma non esiste una formula assoluta. Ecco la bellezza del ray tracing. Il ray tracing ti tiene automaticamente conto di tutto questo. Ok? Quindi indicativamente è un rapporto 1:3. Nella realtà dipende da caso per caso. Ok? Absolutely.
The position per
Absolutely. Absolutely, Luigi. That's the reason why we say that the pseudo-phakic biometry, it's very important that it has to be calculated in an accurate way. And where is Nicola? Nicola? Okay. Nicola, do you agree with me that defining basically the velocity in the media is of a fundamental importance, because basically, to calculate the position, we need exactly to define the media where we are moving. And again, however, to calculate the ideal IOL, the future will be using not just standard formula. Any formula, basically, it's a compromise. The reality is the ray tracing. And to define an IOL, the true process that should be followed is analyzing detail the cornea, okay? Have a very good information on the cornea, have a trustable biometry, biometry in such a case, and then set in advance which type of IOL you want to use, because of course it will be a big difference if you say spherical or torical IOL. And finally, the root mean square of the error of the point spread function will tell you exactly which one is the IOL to implant. That's the way. Good.
Depends on the forces of the liquid inside that are different in the surgery.
Absolutely, Paolo. That's while when you work on the cornea, you are sure that you are making the ablation over there, and that's the reason we strongly recommend to use. We are totally enemy. You remember the old, adaptive IOL, which was terrible because basically no control at all. We are in favor of using IOL, which they have to be very stable, because basically the predictivity of the positioning of the IOL will minimize the error. I fully agree with you. And that's the reason we say that at the end of the day, a remodeling of the anterior shape may be useful if there is a dislocation. With our software, we can show you how much is the role of a Z dislocation in terms of refractive power. I can tell you that if you have a movement of the IOL of about 500 micron, your refractive error will be about half a diopter. Of course, this will depend how much is, but just to give you an idea, okay? That's the reason that basically predictability is make an error of 0.5 diopter is very common, but because this is the reality of this kind of subject. So, of course, I will never suggest to make a corneal remodeling for a refractive error of minus 0.5, considering that those patients will be 70 years old. But if you have an error, a relevant error, then for sure we can compensate for it.
There would be young patients, and then they really want the correction of 0.5.
Absolutely.
So
Absolutely. Even if basically, not, you know better than me that when we deal with multifocal IOL implantation, then basically, you know, it will be often, it may be, you know, basically a spherical offset. In such a case, our suggestion will be make a corneal remodeling, targeting, of course, the infinite distance, and assuming that the IOL was designed such to compensate for it. Okay. Of course, all of this is based on the fact that the effective power of the IOL is equal to what is declared on the paper, right? Because this is another relevant point. Well, any further question? Let's play with this case and change, just to give you an idea, Pasquale, I will show you. If we change, for example, from 100 micron offset to 200 micron offset on X, how much in the ablation it changes, okay? So now we go in Edit. This is the operation that you should do if you want them to change in the real time, okay? So you go in Edit, and you change the parameter that you want to change. Now, we process. You have to consider that the time to reprocess an exam, depending from the complexity of the exam, may take from 2 minutes to 3 minutes, okay? Now, what we do expect that the ablation will be more pronounced, because basically we are doubling the distance. And as a consequence, we do expect that the refractive zone will be reduced in order to minimize the discrepancy. Okay. This also depends from the connection, the quality of the connection that we have, of course. So basically now we see the refractive zone was reduced to 2.5, as you see. But if we now see the quality of vision, yeah, now it's producing all of the surfaces. And overall, as you see, the epithelium, of course, is removed only in the region that it's interested from our ablation. The connecting zone was brought up to 9.2 millimeters. And finally, our target here is exactly to double, basically, the ablation. Total ablation in such a case is 110 and 14 micron. And here now we see that our point spread function has a much larger offset than before. So basically, again, generally speaking, go up to 300 micron is, I would say, a limit that we would not like to overcome. So, any question? We may then anticipate some of the, actually we compressed the time. We were in delay and now we are in advance. So I would suggest to have more time than for the wet lab. And if Pasquale, would you start make your first introduction? So Pino is using our system from 6 months, and they are using the system only for complex cases. So,
hello everyone. Just because I love risk, I use just for complex case. You know everything because Giuseppe this morning explained everything about ray tracing and about the system. we have two classes of patients. Patients having a corneal ectasia and patients having a regular cornea. Here, sto muovendo tu. Faccio io. Grazie. Here you can see the ideal corneal shape and the ideal shape. And in this part of the picture, you can see the difference between the refractive zone and the curvature. What about this? As Giuseppe this morning said, if you want to correct something about like this, you can think to take away all this part, but if you do like this, you don't consider which is to contribute to refractive zone of this other side. So if you move totally this on the focal point, you have this overcorrection. This consent to reduce the quantity of tissue that you can take away, and you can do a minimal stress treatment, and you can obtain a double goal, reducing the effect of this scar or the formation of the anterior surface of the cornea, and have the correct localization of the focal point. We are presenting some patients. 14 eyes in 12 patients were treated with average follow-up of 3 months. You can see the pre-op incorrect distant visual acuity and the pre-op correct visual acuity. And I don't know if you're able to see everything, but I think it's not important. You can have the slide whenever you want. And then we go directly here. The first patient, age 24, male, left eyes. He had a cross-linking treatment with ontopoiesis epithelium hope and had some complication with scar all over the corneal surface. This was the anterior elevation map before the treatment. This is the anterior curvature. You can see the anterior, the stromal map has changed. This was just what we wanted. And this is the posterior. This is the differential map between the anterior curvature. This is the refractive zone 3.8 millimeters. The connected zone was larger, and the maximum depth was 56 microns. And what we had this condition. Follow-up 125 days. The ratings map power difference from the anterior. Look how the anterior changed, the anterior surface. The stromal doesn't change so much, but because of the posterior curvature, you can see how a little change in the anterior surface of the cornea with the surface of the posterior cornea untouched reached these results. The results was good. Not so much because he increased just one line, but he was very satisfied. The quality of vision was better than before. And this was the cornea before the treatment. And we treat just the central part. And you can see this cornea, because it was thin, we made a cross-linking treatment too. And you can see the demarcation line here. This is another case, a 46 male, post-traumatic irregular astigmatism. This is the anterior surface difference before and after the treatment. This is the stromal changement, and the posterior was the same. This was the zone of treatment, refractive zone 4 mm, connected zone very larger, maximum depth 98 microns. And this was the ray tracing power map. Look at the anterior surface and the total. The actual visual acuity before was 3 lines with this correction, and after we had 5 lines with this correction. So we cannot change totally a condition, but the purpose is just to improve and just to change what is enough to make comfortable the vision of the patient. These are not normal eyes. This was the pre-op, and this was the post-op condition with pre-op microns pachymetry and post-op. Here we have another patient, 45, male, high astigmatism, before, after, stroma, posterior, ablation area, refractive zone 4 mm, connecting zone 9.6, maximum depth 77 microns. And this is the ray tracing power map difference, the anterior, but look at the total, and was just here. He passed, his visual acuity changed 5 lines to 10. And this was the pre-op and post-op. This was in the same patient, the second eye. Pre-op, post-op anterior surface, the stroma, just better. Posterior, the same. The ablation area, refractive zone 4 mm, 920, and then this was the final result. And this was the pre-op condition and post-op. This was how thick was the cornea before and after the treatment. This is another patient with a central glaucoma, 46, before and after the treatment, and the anterior surface and the stroma and the posterior surface remain the same. This was the refractive zone 4.6 mm, connecting zone to 7.9, the maximum at 95. And look here, the anterior, and this was very interesting, the total. They passed from these 3 lines with 9 to 9 lines with 1 diopter of myopia. This was the pre-op condition, and this was the post-op condition. This was in the same patient, the second eye. Active zone. On 5, 7 line. Look. This was an anisometropia with compound myopic astigmatism and amblyopia. This was the anterior surface. This was the comparison differential map of this, the stromal before and after, and internal. This was the refractive zone, the connected zone 8.3, maximum depth 100 point. And this was the differential map, our ray tracing power map for the anterior surface, but what important is the total. And look, 8 with 7 diopters, and 10 with 1.5. This was the pre-op condition of the cornea. You can see a thinner cornea, and the difference you can see. And it was from 553 to 421. This was a female, 68 years old, and was a post-PKP astigmatism, 3 months. These are 4 months. This was the pre-op and the comparative pre-op post-op of an anterior surface, the stromal, and the posterior. The CMI passed from 44 to 28. This was just a very, 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 very narrow area for treatment, 1.2. And Giuseppe told you before about the crumple vector. Connecting zone larger, the maximum depth 55. And look at the difference. This is the anterior conditions. This is the stroma, and this is the total. Visual acuity was 6 with this correction. She lost 1 line, but she was very happy because I couldn't use these glasses to see. And it was the pre-op condition with the thickness of the cornea, pre-op and post-op. This is a very interesting case. It was the case of corneal dystrophia, reticular dystrophia type 1. And this patient was 78 years old. And he presented with this epithelium hyperplasia. I tried to treat it with drops Then I thought to remove mechanically the epithelium just to see what happened. And for 2 times I removed the epithelium, but the epithelium grew in the same way. And so I thought maybe it was the problem of the Bowman condition. And I suppose that with laser, removing transepithelial laser, removing the epithelium with just the higher layer on the Bowman, something will change. And that was the results before and after. This was the anterior surface. Wasn't possible to take the stroma because of the cornea, posterior, with a differential mark. This was the ablation area, 3.8 refractive zone, connecting zone 9, very large, 9.1, maximum depth, 90. Almost 100 was the thickness of the epithelium. Never see nothing like this. And this was the ray tracing map, differential of anterior, stroma, look here. He was very happy, and this afternoon we are going to treat the second eyes during live surgery in this patient. And you can ask what you think about the first eye. The pre-op was this incorrect distant visual acuity, and the post-op was this. He had glaucoma. It's just a book of ophthalmology inside one patient. 2 times operated for glaucoma. And this is the cornea before and after the treatment. And this is another cases of keratoconus. Here now we are going to the ectasia cornea and correction. You can see the differential map of the anterior surface. Here the pre-op, the post-op stroma, and the posterior. Look how the CMI, Giuseppe explained what is CMI, I don't repeat anything, from 30 to 6. Refractive zone 4 millimeter, connected zone 8.2, maximum depth 49. And this was the final condition. This is from 6 to 6 without any correction. But I can say you, the patients are satisfied. They don't care about the refractive condition, but they are satisfied because the visual acuity is important, but the quality of the perception of the quality of vision is much better. This is the pre-op, and this is the post-op. Another case, keratoconus, 40 years old, anterior comparison map, stromal, pre-op, post-op, 31, 5.66. Refractive zone 4 millimeter, connected zone, and 51. Look at how thinner is the ablation thickness from 80 to 50. And this is the visual acuity. And this was the condition of the cornea pre-op, post-op, and the thickness. Here's another case, I think the last one. 20 years old, keratoconus, 28 days, anterior, normal, posterior, 2.4 refractive zone, and this was the difference. 130, 3 to 5. Look and look after the laser. Okay, thank you very much.
Pasquale? Question? Pino.
È interessantissimo. Ti volevo chiedere se puoi riprendere rispetto al paziente numero 4, quello che c'era il problema di leucoma abbinato dall'altro occhio miopia elevata. Perché in un occhio ci sono poi la somma di tutte le possibili. Vabbè, avevo un leucoma centrale e dall'altro occhio avevo una miopia elevata. Il paziente 4, numero 4. Sarà questo? Allora, ti volevo chiedere, in effetti se ho ben visto, mi sembra che, c'era lo spessore residuale che era 3,67 post-op, giusto? Diciamo che almeno i sacri testi a suo tempo ci dicevano che parte il discorso di 3,80, 3,90, eccetera. In effetti, sulla base della tua esperienza, è un qualcosa che va, diciamo, si rimodulato questo tipo di valore?
L'esperienza
chiedo perché così è più importante anche per noi, perché purtroppo
I was asking me if the residual thickness under 319 is safety for patient if something changed in the time. I don't know what it will happen. We have two options: or lamellar keratoplasty, dark, or just before, try and see what happens.
Yeah.
And because I'm joking now, Barry take all the patients for keratoplasty. I'm just trying to take away a little group of patients to operate to the next year. But in the next year, I hope to show you how is how he will be from Estarà. And I don't know if something change, if the cornea will change its stability or not. We didn't do cross-linking. We just remove and see what happens. Okay. Maybe we could do two things. If the cornea starts to move, we can try to stabilize the cornea with a cross-linking and see what happens. At the end, if it doesn't work, we can think to do a job. That is, but I don't know if maybe you can start directly with the doll. But I think if you are more conservative, just to try. The patient was informed. Okay. And the patient was informed and he accepted. And he knows that maybe in the future he will need something called surgery. But it's important because many things are changing. When the refractive surgery started, all the corneal refractive zone were standardized, 6.5. Epithelium standard, 50 millimeters, and everything was the same for every patient. But that is not what we do when operate a cataract. That is not what we do when do everything in the eyes. So we are trying to understand how we can do a customized work, eye for each eye. And I hope the next year I will present how the patient, the condition of the patient. And I hope to show you another picture under here that is the same like that, with the same thickness and with the same tomography. Okay.
Now Pasquale will present an interesting case of a pseudo-phakic eye, ectatic, with an IOL implantation. He will speak in Italian, but if you have any question, then we may translate.
Buongiorno, sostituire il professor Alessio è già un'impresa difficile. Sostituirlo prima di, cioè senza saperla, diventa ancora più complesso. Va bene, questa è la presentazione che il professore ha pensato di proporre oggi. Allora, io vorrei dare un taglio un pochino più, diciamo, coinvolgente, in quanto noi andiamo a... vi proporrò un caso clinico di un trattamento, un paziente pseudo-phakico. La considerazione che vorrei fare con voi è che l'intervento di cataratta è sicuramente l'intervento più diffuso che noi facciamo. Il pacchetto dei service cataratta è un pacchetto che prevede un rimborso strettissimo dal punto di vista economico per l'azienda sanitaria. Quanti di voi nel pacchetto della cataratta eseguono la topografia al paziente prima di portarlo in sala? Penso pochissimi, a parte, diciamo, rari casi. Quindi molto spesso potremmo trovarci ad operare pazienti con un keratoconio stadio iniziale 1-2 di cataratta senza nemmeno saperlo. Questa cosa potrebbe condizionare sicuramente il calcolo della lente, in quanto già sapere che il paziente c'è keratoconio prevede una complessa valutazione nel calcolo della lente. E anche qualora questa venga fatta, comunque potremmo andare incontro ad errori di target refrattivo o a sorprese refrattive, cioè anche facendo le formule di terza generazione, quelle basate sull'intelligenza artificiale, che è l'unica, la Kane oppure la Barrett 2, potremmo andare comunque incontro a errori refrattivi, in quanto c'è un errore nel calcolo dell'effettiva della posizione della lente all'interno intraoculare e una non considerazione della componente della superficie posteriore. Bene, noi anche qualora ci trovassimo di fronte a un errore refrattivo post cataratta, possiamo rimediare come tramite quindi il trattamento laser customizzato mediante il ray tracing e con il nuovo software dell'iVis. Ci sei? Ok, e questo nel caso. Caso clinico è un paziente di 60 anni, tra altre cose collega medico ortopedico, quindi in piena attività lavorativa, sottoposto a intervento di cataratta, a cui è stata eseguita la topografia prima. Quindi voglio chiarire questa cosa, che noi abbiamo fatto di tutto per azzeccare il calcolo della lente, con un keratoconio stabile, quindi, però siamo andati incontro cioè il paziente presentava preoperatoriamente, quindi prima della cataratta, 42, un'irregolarità corneale di 42 micron. Questo era il potere corneale totale, il ray tracing, con un visus di 5 decimi. Il paziente, come detto, era un collega medico che operava e quindi aveva difficoltà quindi nella sua vita quotidiana, quindi aveva una qualità di vita non soddisfacente. Quindi si è ritornato alla nostra attenzione e abbiamo pensato di acquisirlo mediante il preciso e di elaborare, quindi tramite non i parametri refrattivi, ma tramite i parametri biometrici, impostando e sapendo quindi la lente impiantata, per cercare di ottimizzare il risultato visivo del paziente. In questo caso, vabbè, non si leggono i dati, non so se voi li leggete, però abbiamo 5 dioptrie di astigmatismo soggettive. Abbiamo eseguito un'ablazione minima di 36 micron di ablazione stromale con una zona di connessione di 7,10 e una zona refrattiva centrale di 1,9, quindi molto piccola, che andava a compensare, quindi la superficie anteriore andava a compensare l'ectasia della posteriore con una riduzione delle irregolarità morfologiche corneali. Questo è il post-op. Il post-op è interessante perché nel ray tracing del post-op noi abbiamo comunque l'astigmatismo corneale. Questo astigmatismo serve per compensare l'astigmatismo della lente torica interna, perché aveva comunque una lente torica, cioè non era una correzione, diciamo un errore refrattivo, ma è stata una sorpresa refrattiva quello ottenuto post-intervento di cataratta. Questo paziente, dopo fatta l'ablazione, al momento vede 9 decimi, è pienamente soddisfatto. Questo tipo di casi sono complessi in quanto l'analisi, cioè il visus refrattivo soggettivo è difficile da quantificare e un trattamento basato solo sul soggettivo andremo a non avere un risultato visivo ottimale, in quanto cioè, le aberrazioni corneali intrinseche non verrebbero compensate. Diciamo, questo è il caso clinico che ho proposto ed è stato il nostro primo caso di paziente pseudo-phakico. Ne abbiamo avuti altri, uno trattato venerdì che aspettiamo a controllo. Come esperienza abbiamo una casistica molto ampia sul cross-linking cTen, quindi customizzato e transepiteliale no touch. I pazienti pseudo-phakici al momento non abbiamo tantissima esperienza perché diciamo sono casi un pochino più rari fortunatamente, ma che sicuramente andremo ad implementare in quanto, cioè, nel senso, i pazienti con keratocono sempre più spesso andranno a fare interventi di cataratta. Questo è il caso clinico che il professore pensava di proporre. Non so se l'ingegnere.
Alex, it was in Italian language, but I mean the maps were quite clear. You know, the toric astigmatism on the cornea was clearly explaining the compensation, considering that the IOL was 5.5 diopter, 3 diopter in cornea, exactly match for this one. So it's 1 o'clock. Cosimo, half an hour for you. Yeah. Cosimo is using our platform since quite a lot now, so he will provide his feedback on basically mostly on ectatic cases.
Thank you, Giuseppe. So, first of all, before to show you the clinical data of our study, I would like to share a scientific up-to-date about the TRK cross-linking. We know that the possibility to use cross-linking alone is basically linked to early diagnosis. So the early diagnosis of ectasia is the key of success. So you don't need to empower the refraction of this patient if you do an early diagnosis and an early cross-link. This is an interesting study for Professor Price showing the satisfaction rate of cross-linking alone. And as you can see, a major part of the satisfied patients belongs to the early diagnosis, to the stage 1, and are the younger patients and the under 20 years patients. So we know also that in other cases, cross-linking has paved the way for combining PTK and PRK with cross-linking itself, because cross-linking strength on a stroma stabilized the progression of the ectasia, conferring an higher level of strength, sensitivity, and efficacy to this approach. However, you know that ablation of corneal tissue is not widely accepted. So we work off-label when we do this treatment today. However, these kind of treatments represent a therapeutic reality that is performed for more than 15 years. So we have more than 15 years of follow-up in Europe and other countries, of course, in selected cases, and we need to find a global consensus with shared guidelines, because it belongs to the therapeutic flowchart of keratoconus today. Where we are, this is the flowchart of therapeutic flowchart of keratoconus, and we know that cross-linking now is the leading therapy of keratoconus worldwide. So where we are generally in stage 2, crossing to stage 3, patients with poor or insufficient spectacles visual acuity who are intolerant to contact lenses. So, patients who are intolerant to contact lenses can be studied and eventually scheduled for this kind of treatment if they have the parameters to do this kind of treatment. So here, cross-linking means central corneal remodeling. Purpose is that there is a therapeutic approach. It's not a refractive approach. We don't want to remove spectacles, glasses. We want to improve the quality of vision with spectacles, with glasses. We're using the high-order corneal aberrations, regularizing or remodeling the corneal shape, reducing the spectacles' nocturnal fluctuations, these patients, consuming the small amount of corneal tissue, giving a new chance also for a new contact lens refitting, and avoiding or at least postponing corneal growth, improving quality of life of these patients. These are the pioneers of these techniques. John Canelobos was the first, started in 2007, and was followed by George Quinones, you know, the Athens protocol, the Cretan protocol, the CCL. This is the studio in Julian Blay. That's what's very important. And our study with the selective transitive ablation, the SafeCross protocol, that I shared with my colleague Miguel Requiqui. So there are these new developments that are improving the results, and we are expanding the indications. This one This was one of the most important features for the decision making to include the patients. Stable and acceptable visual acuity, we only monitor this patient. Unacceptable visual acuity, yes, we can do cross-linking plus and trans-PRK or trans-PTK. In this flowchart are not included contact lens. Contact lenses first, then the parasurgical approach eventually. Okay? This is my personal flowchart. You can see because we have included the contact lens. Consumption correct this visual acuity. Of course, I prescribe the contact lens. If contact lens is not well tolerated, so I go inside and eventually include these patients for crossing plus on regularization or remodeling. These are the long-term results reported in the literature. These are the 10 years outcomes. So it is a very good period. But then, as you can see, 45% of the patients gained more than 2 lines and uncorrected distance visual acuity, and about 40% gained 3 lines or more for corrected distance visual acuity. These are the average data reported in all literature study in over 10 years forgot. No one of the study reports adverse events except a few that I will show, and no aids or instability of these cases despite the reduction of corneal thickness. And John Danilopoulos went 100 microns over the stromal bed, also under. The problem is this. We have Athens protocol, Clayton protocol, CCR from iVis. We have the Topo-Link protocol from Eric Rosenberg in New York. We have the version 2 of cross-linking protocol from Julio and Alexander. We have the Tel Aviv protocol. So, there are some common rules that all these protocols share. 50 to 55 microns of stromal ablation. Optical zones between 5.5 and 6.5. The feeder stromal band is between 300 and 450, even included. So someone goes to 150 microns of no, jumping a lot. Age at conclusion, not pediatrics. But the analytic age of inclusion is over 18 years old. However, in some studies, there are some pediatric cases. So the range is between 14 and 30 years old. Again, the stage is common for all the literature data. Stage 2. Stage 1 to stage 2. According to the micron classification, of course. Again, plus 2.3 and that's from 1 to 4. the lines of the thing. Take a look at the confusion in the cross-linking protocols. Of course, 3 milliwatt, the protocol, 9 milliwatt, 50 milliwatt, 80 milliwatt, 30 milliwatt, pulsed light, continuous light, 5.4 joule, 6 joule, 7.2. Global consensus and guidelines needed. This is the most important conclusion of this slide. Another debate, simultaneously or sequentially? Both. You can do both. You can do simultaneously, PLK, transepithelial PLK, of course, and cross-linking, and you can do a trans-PLK after cross-linking if patients are not satisfied from the visual acuity or becomes intolerant lenses. Of course, there are pros and cons doing together, but what's about literature? There are no comparative literature data about this. This is only one paper of 2010 from John Candelopoulos comparing if it's better simultaneous or sequential. So if we go and search literature, the literature demonstrates that the sequential cross-linking and then PLK after 6 to 12 months from cross-linking have comparable functional results of simultaneous treatment in absence of adverse events and complication induced by a different rate of ablation as you can tissue, so you can do both. You can treat even patients. Sleeping can be treated with a guide, with unguided laser ablation, and correct distance visual acuity and uncorrected distance visual acuity, reducing the eyeball aberrations. There are papers in literature that show that caution must be exerted in this combined treatments for an increased AIDS percentage. Go inside the literature is not true, because the long-term data don't show a higher percentage of AIDS in these combined treatments. If patient selection is correct. I have shown that in this nasal view in computer microscopy that we don't have higher percentage of AIDS in congruent treatments if patient selection ocular surface analysis before excluding blepharitis and some ocular surface conditions that may be predisposing factors to inflammatory reaction, keratocytes activation, and stimuli. And with also a good therapeutic pharmacological regimen using steroids since the beginning of this treatment, immediately. Of course, also the cross-linking have runners, because we need to know our residuals from a bed and then doing the cross-linking that is customized according to our residual pachymetry. We can use accelerated cross-linking in pulsed light and also know the fluorescence to predict our demarcation line and our volume of cross-linking. I published these nomograms a lot of times, also in my last book. We have the columns. We have results of the CNI study 2 on 9 milliwatts. We published the advantage of using the pulsed light to reduce the wound stimulation on the stroma. And I think that in the iRes 2 laser also is included. But before that, I show you the results. I want to go back to the literature. Which was the problem? The problem was showed very good by Dr. Addabbo. See, we regularize completely the anterior surface irregularity, we induce an overcorrection. The overcorrection was one of the main problems of the treatments reported in the literature. In people, they try to compensate, reducing the sphere, reducing the cylinder, down 30% or 70%, but because they didn't use the ray tracing technology that CIPTA introduced it finally. So, thanks to iVis, and thanks to, take a look here. Show progressive alteration and hyperotic shape. These are the reports of the long-term data in the literature. Very well this slide because Dr. Addabbo showed you that regularizing all the column, they taking into account the steer contribution that we can avoid the correction, and they can spare tissue. So we have a double advantage, of course, using replacing technologies, because we avoid overcorrection and we spare tissue. Of course, we spare tissue also using the SafeCross effect, so reducing the optical zone and working on the connection zone. So you can see here the anterior tracing gap, the posterior contribution that reduces the total power. So if we don't treat this completely, we treat only the seeding part that is not compensated from the posterior. Is avoid overcorrection. But it isn't that, of course. Giuseppe finally resolved for us a great problem because the peculiar refractive contribution is very important and must be included in our calculations. Of course, we need a full treatment customization. These treatments must be performed transepithelially. So it is clear. This is one of the last also from Giuseppe. Is the introduction of the time in the world of the SafeCross. SafeCross is a new riboflavin that gives us the possibility to boost clinically cross-linking because the higher percentage of superoxide anion, increasing the amount of cross-linking, including the primary kind of license for the reaction, using the shocking time and also sparing energy. Okay. So using the job. And we've done the 7 minutes of current talking. 7 minutes are enough. And the optimal viscosity and very applied osmolarity solution. I have published this first work in the Journal of Clinical Medicine in 2021. You can see you have very deep complication lines. SafeCross has about 30-35% of efficacy by because with an enhanced biopsy production, it is aggregate 1.5 milliliters, allowing to reduce about 40% of irradiated energy. This case was the soy congress, I'm sure you remember in Lecce, in the live solidization. So we need to change our mindset, of course, and favorable approach, and we need a good treatment customization. And the iRes suite, hello, this is my center in Siena. And finally, I found that this platform with my patients and to me the greater satisfaction with this the panorama of the technology available for this kind of treatments. This is the Siena replacement study. We have the data in preparation now. With more than my slides, but I will show you only the eyes that have 4 years follow-up. So long-term follow-ups. We have 20 eyes, 20 eyes, stage 2 and 2 stage 3 that required but all the eyes, the 20 eyes were CIPTA 1. The one, and only you can see it was P2. So where young adult patients, because in the beginning we choose to treat adults. And was over 21 years in the case, between 21 and 46. 12 eyes were treated simultaneously, replacing the fertility guided cross-linking nomogram, and the 10 eyes were treated after cross-linking. So we try to do a comparative study. It was a platform was the iRes, the software called the CIPTA 1, and the suite. A new follow-up is 82 months, it is over 4 years. All patients completed this follow-up, also presented here. No permanent AIDS in any case, influencing negative visual activity. No ectasia relapse. This is really important. Despite reduce the pachymetry, and then we saw also once to this patient, we have a maximum follow-up in some cases, and we have a regular patient satisfaction. Those are the results of uncorrected and corrected visual acuity. I can see that the gain was higher than the average gain that is reported in literature. The average gain reported in literature is 2.5 to 3 lines. We have 4.3 lines of gain using rotating. And we have 3.57 lines on average in the uncorrected visual acuity. So we go higher to the average results of the other platforms using rotating. Take a look at this slide. I think this is very important because about 68% of our statistic gain more than lines. And the rest 22% and only 2% in water. So the middle part of these patients even had over 4 points. This is amazing because we go from 5 to 10, from 6 to 10. The major part of these patients linked to 2020. It's about the mass, the immune capillary power. You can see here the average reduction, 0.5 diopters, the immune capillary power, taking into account the anterior and posterior diopters. These were the two subgroups. As you can see, it is higher on the simultaneous treatment. But why? Because at the time of inclusion, the Kmax of the simultaneous treatment was higher because they were more advanced cases. The cases who did first the cross-linking were less advanced because they had a better visual acuity at the beginning, so they were treated only with cross-linking, or then they were good contact lens wearers, so they did cross-linking first, and then we, after the PFK, where they become intolerant contact lens. This is the sorry, the coma reduction. You can see that the coma reduced by from 0.5 on average to 0.3. These are the aberrations and the photographic cylinder. These are a lot of cases with another instrument that we use also to check this patient beyond the precision. You can see the representation, the pre and the post-operative. You can see here the points per functions. I will show you another important data to conclude. In post, this is the reason why it is not universally accepted that this kind of treatment, because we reduce corneal pachymetry. Of course, the reduction of corneal pachymetry, you can see here we go an average of 400 in the epithelium, but we have a range between 350 and 440. So we go also under 100 microns, and we don't have instability, we don't have ectasia relapse, we don't have complications. And you can see here the posterior elevation follow-ups. That is really important to screen the stability of the keratoconus and then track to posterior elevation. And posterior elevation is really important in you can see here a lot of posterior surface. These are, you don't need probably the years, that is 2019 and 2022, yesterday. So 4 to 5 years follow-up. And we have a stability that is clinically and instrumentally proven in our statistics. There is another case that treated but of course we just knew that everything is good in this kind of treatments. It is the points per function for the vision. Another important thing. This is the conclusion. Don't use mitomycin after cross-linking, because it is demonstrated in literature that induce further keratocytosis. We stop the differentiation of monofibroblasts through keratocytes, taking the cleaning the collagen, disorganized collagen, so increase the probability of AIDS used mitomycin instead of reduce the probability of AIDS. This is really important. And this is my conclusion, the consideration that my experience using the ray tracing algorithms in this suite, we have better functional results compared to all literature data reported. So, thank you very much, Giuseppe.
Thank you for your wonderful presentation. Any question for Cosimo?
With the SafeCross only and the SafeCross Plus, the stroking time and the irradiation time is changing or is the same?
Stroking time is 7 minutes with SafeCross. We reach an enough concentration of riboflavin inside the stroma to do a POF cross-linking. In an exposure time of 3 minutes with 18 milliwatt or 5 minutes, according to, of course, the stroma thickness that we have. Yes.
If you compliment for your presentation, if you showed some cases in which you do the regularization after cross-linking 1 year or 2 years after. Yeah. In these cases, you do another cross-linking on only the regularization.
No, Giulio. I didn't do the cross-linking. I checked for the demarcation line, and sometimes with an OCT, with an angle resolution OCT, I will check if I have the demarcation line still visible. Anyway, I don't repeat cross-linking, and no one of these patients repeated the cross-linking.
Only 6 years after 2 years after cross-linking.
No problem. They were stable.
I think to pediatric patients, for example, 16 and 16 years, that we need to do cross-linking as soon as possible. But we don't know if they are tolerant to contact lens.
No.
If they have a bad quality of vision or bad spectacular vision, but we need to do cross-linking immediately. Yeah. So I think in this patient, the regularization, I can do it after 1 year if they are don't tolerant to contact lens.
Yes.
Cosimo, complimenti per la relazione. Ti volevo chiedere, sempre un discorso su cross-linking e PRK, PTK combinati, se combinati o simultanei oppure distanziati. In effetti io ho iniziato con il discorso di farli differenziati, anche perché sulla base della mia esperienza c'era il discorso che un cross-linking ha degli effetti modificativi della forma dell'asse anche per un certo periodo di mesi. Ora, e quindi insomma l'ho spostato nel tempo. Il fatto di farli simultanei rispetto a questa, diciamo, possibilità che spesso come viene diciamo considerata questo discorso, cioè nel senso tale rispetto a dire ok, faccio il cross linking, aspetto che si blocchi, che l'asse non si modifica più o meno e poi faccio il trattamento su questo, rispetto al fatto di farli assieme e quindi insomma tra virgolette cercare poi di indovinare poi come, in che senso vada a finire, cioè nel senso per dare il massimo del risultato. Come riuscire come tu sei riuscito diciamo, a combinare da un lato il farli assieme, chiaramente anche diciamo organica, un discorso razionale, e di fare in modo di avere il massimo risultato possibile avendo lo status definitivo della cornea. Grazie.
Grazie a te della domanda, perché è una questione ancora aperta. Dal punto di vista della letteratura, come hai visto, non ci sono dati comparativi sufficienti. Nella nostra casistica noi non abbiamo avuto differenze statisticamente significative e questo mi ha portato a fare un po' un passo indietro e quindi a dare ragione a Giuseppe, perché io ero molto critico soprattutto nei trattamenti combinati e quindi la pensavo esattamente come te, cioè preferivo filosoficamente aspettare gli effetti e valutare l'impatto diciamo del cross-linking pur sapendo appunto che non è prevedibile. Questa è un'altra questione, ma sicuramente quindi fare eventualmente l'ablazione. Poi avevo anche un po' il timore di indurre un eccessivo stimolo sullo stroma e quindi di avere degli AIDS. I dati di lungo termine non dicono questo. I dati di lungo termine dicono che non c'è un incremento dell'AIDS, che non c'è un'ipercorrezione, perché quello che dici tu poteva portare a una pianificazione di un certo risultato che poi andava oltre per effetto dell'appiattimento dovuto al cross-linking. Anche questo non si verifica, probabilmente perché quando noi facciamo un'ablazione simultanea, in qualche modo andiamo pure a compensare l'effetto del cross-linking stesso in termini di appiattimento. Questo è quello che penso io. Quindi noi eliminiamo una componente, diciamo, di retrazione stromale, chiamiamola così, che può essere quella che porta a quel drift, diciamo, cross-linking di per sé. Quindi comunque i dati di letteratura confortano tutti noi, perché questa è un'apertura for everyone of us. We can do both. We can do simultaneously and we can do after. Se ho un paziente che è già stato cross-linkato e ha necessità, lo posso fare senza problemi, ma se ho un paziente naive che ha bisogno di un cross-linking e di un trans-PRK perché non trovo il contatto, a quel punto vado simultaneo. Certo. No, la mitomicina non deve essere usata, invece che era qualcosa che noi esportavamo dalla chirurgia refrattiva, della miopia. Ma questo invece è il cross-linking che determina. Il problema non è usare la mitomicina after PRK, perché usare la mitomicina after PRK va bene, ma usarla dopo il cross-linking è il problema. Esatto, che già invece è una apoptosi, come giustamente dice lui, quindi aumenti l'apoptosi. Ricordiamoci che gli AIDS si riducono grazie agli stessi cheratociti e alle collagenasi. Ricordo anche che il cross-linking ha un effetto anticollagenasico. Poi andiamo a inibire anche la collagenasi. Se noi inibiamo la collagenasi, quando va via quel tessuto cicatriziale? Mai. Rimane lì, si cronicizza, quindi poi hai l'AIDS persistente, perché nella maggior parte dei casi l'AIDS è temporaneo. Se non aspettiamo, andiamo il cortisone, magari ci mette qualche mese in più, un anno, però va via. È un clearing fatto dai cheratociti e dalle collagenasi. Ma se noi impediamo, aumentiamo l'effetto apoptotico, lo triplichiamo sostanzialmente con la mitomicina, inibiamo la collagenasi, praticamente il clearing dell'AIDS non ci può stare.
Può aver senso a conforto della stabilità valutare l'esteresi corneale con il Corbis, uno strumento del genere o no?
Ma non devi fare proprio a me questa domanda, guarda. No.
No, ma no, grande, perché? Perché, vedete, adesso qui non mi permetto di parlare perché Cosimo è stato un grande con la sua presentazione, però pensiamolo dal punto di vista adesso, vediamolo proprio, la cornea è un po' come una piccola cupola in pressione, no? Cioè, proprio strutturalmente si comporta proprio come una cupola. Ora, voi dovete sapere che nel processo di deformazione ci sono vari parametri che interferiscono. Okay, let's speak in English, excuse me. Okay. So basically, the question was if devices like Corvis, they can basically predict either the elasticity module or as always basically the future deformation. So in order to basically analyze the deformation, the only way, and I'm telling this as an engineer now, okay? The only way to make an analysis of a complex structure is to make a finite element analysis, okay? So what is finite element analysis? You have to know the entire shape of the body that you want to analyze, and you divide in very tiny cells the structure, and you study the interaction between the cells. So this means that you need to characterize, first of all, you need to know from limbus to limbus, the total shape. Let me tell you that the parameters that will affect the deformation are several, it's not one. And the role that they play differs in terms of importance. So when you want to study basically the deformation, the most important parameter is how large is the cornea, how big is it? The larger the cornea, the higher the deformation. And you learned it also with the old microkeratomes, you remember, right? There was basically very big risk when the cornea were very large. You know it. Then it comes the average curvature. A very flat cornea, much higher risk of deformation of a curved cornea. Those parameters, the first one is play a role up to the fourth power. The second one up to the third power. Then came the thickness. And imagine that the elasticity module play just a linear role. So if on theory you would like to measure the elasticity, just Corvis what they say. I send them up and they see the deformation, and as a consequence I measure the elasticity. This is the most stupid thing that I ever heard in my life. Okay?
Completely unuseful instrument.
Absolutely, completely unuseful instrument. I mean, it's totally unuseful for the main reason that in order to measure the, you know, the only way it could be useful if you have exactly an identical cornea with the same diameter, with the same, but if you want to compare two different cornea, due to the reason that there are parameters that they play a much more important role in the total deformation, claiming to measure the elasticity just looking at the deformation is totally stupid. Or stupid or in bad faith. Okay?
Very most easy effect one of the goes down after cross-linking. So, but it's the same cornea, right?
Absolutely.
Yeah.
Now, exactly. Now, if basically you are comparing the cornea with itself, then you may deduct, you know, if there is. But this does not mean that you are measuring the elasticity module, because basically in order to do this, you should make now the only device in the market that is conceived really to measure the elasticity module is a machine based on Brouillon methodology, because Brouillon methodologies analyze basically really cross-linking, excuse me, the elasticity module, okay?
In italiano comunque insomma sposo perfettamente le cose, e in tal senso voglio dire che su effetto diciamo dell'azienda che poi produceva questo il combinato Pentacam Corvis, no? Tra l'altro il Corvis era stato riesumato perché era nato come tonometro a soffio molto tempo fa, per cui ogni tanto ritornano, sai, come una canzone. Ho presi di pazienti che avevano un keratocono, che avevano un occhio, il secondo occhio assolutamente normale. Io ho fatto con il Sirius l'immagine con i colori totalmente normali, quindi era un occhio che se tu non sapevi che l'altro era keratoconico, dicevi aveva un occhio normale. E ho fatto, diciamo, la tomografia. Con il Corvis ho fatto la stessa situazione, erano 18 occhi, fatto queste 18 occhi che anche il Corvis diceva che era tutto perfettamente normale e che non sarebbe successo niente. Di questi 18 occhi, successivamente, in giro di 18 mesi circa, o 4-5, si sono poi lentamente positivizzati. Quindi, alla luce del fatto, anche dal punto di vista, al di là di tutti i discorsi perfetti e precisi, non è servito a niente come discorso predittivo. In ultimo bisogna ricordarsi chi l'ha sponsorizzato e come diceva Todò, anzi Peppino, ho detto tutto.
Allora, thank you for these first sections. What we will have in the afternoon session will be before we will have 2 surgeries, and the surgery will be executed in the hospital of Pino in Mazzotta. These 2 surgery you will see are both cases second eyes. The first one is a keratoconus, and the second one is the second eye of the 70-year-old guy, pseudo-phakic. In between the 2 surgeries, we will have the presentation from Claude, and then some new information on SafeCross 2, and then we'll make the wet lab on the entire platform, and we'll give you introduction on iRes 2. On iRes 2, we will start clinical trial in September. And finally, I will give you a short update on TESS, which is really brand new feedback from the rabbits, and I think you will like it very much. So the surgery, there are the 2 surgeons are Fedele Passidomo and Francesco Pignatelli.
So we stay with CCR. I want to give you some food for thought. Title is a clinical decision tree to support keratoconus patients considering corneal cross-linking combined with refractive treatment. So it is about the discussion, the consulting I actually have with a patient when you consider combined treatment or not. These are very old slides. We first learned from CCR back in 2010, and this was actually proof of principle back in the old days. We anticipated the ray tracing was important, so you can see an ametropic eye, then of course ectasia with the distortion, and then schematically what happens if you smooth the apex, if you regularize the cone, and the impact it has on the rays of light and of course of the visual acuity. This is how we report it in a 2- and a 3-dimensional version. This is just the first 10 patients. We were very enthusiastic and we continued the work. And then at some stage analyzed a much larger cohort. This was a retrospective matched analysis. What you can see on the left is the combined treatments. This is central corneal regularization together with cross-linking. And on the other hand, on the right-hand side, you see cross-linking only. So this is a matched analysis. Patients had the same corneal curvature, same thickness, same visual acuity. As we already learned, our results are actually much better than the ones that are published in the literature on average. So in our cohort, 2/3, 64% of the patients actually gained 2 lines or more of uncorrected visual acuity, which is very good. We also reported on the bad side. We had complications, but I want to point your attention to these lines over here. In the cross-linking only group, 50%, half of the patients improved by 2 lines or more of uncorrected visual acuity, and they didn't even see a laser. And that's remarkable. So when you sit down with a patient and you talk to him, we should do cross-linking, okay, and then you consider, should we do something in addition? Something in addition that is expensive and that you're going to pay yourself. What do you tell patients? How high are her or his chances to actually benefit from this additional laser treatment? And this is a question that cannot be answered from this type of analysis, because the usual type of studies we are conducting is all about efficacy, efficiency, safety, and these answers are all given. So we know it is efficient. We know it is a good technique, but what we don't know, how do we pick the patient that benefits most? But this is a completely different view, a different perspective. So we went back in the original study population. We had slightly more than 200 cases treated with a combined CCR plus cross-linking. We had to exclude roughly half of it. I don't have to go through the list. So they had ocular comorbidities, systemic comorbidities, they had loss to follow-up, whatever. But all the things that happened to a retrospective study. But we ended up with 96 patient potential study population, and we lost 68 due to the matching process. But now we went back to this original study population and matched it with another 96 cases of cross-linking only, so at a much large group. So this is our basis. Then we had more than a dozen potential parameters. We had demographic data like age and gender, we have visual acuity data, we had refractive data, and we had aberrometry data. And now this is a room full of experts, but if I asked you, which parameter would you pick? And if so, what is the threshold value? Then I reckon most of us will be in trouble. Very difficult to say, I look at thickness, I look at Pmax, I look at manifest sphere, you name it. Luckily, this is something we can. Oops, wrong direction. Okay, this is something we can delegate to a machine. This is just to show, of course, we looked at all the individual parameters. We had, this is just an example, we had uncorrected visual acuity preoperatively, post-op in the combined group, in the cross-linking only group. Again, this is a much larger group. We can see that 2/3 gain 2 lines or more, whereas in the cross-linking only group, there were completely different numbers. And this we did for all the parameters. We did it for the aberrometer data, we did it for the cylinder, for the mean manifest, whatever, you name it. And then, next slide. We defined what was our variable of interest. And our variable of interest was an increase of uncorrected visual acuity of at least 2 lines, 2 lines or more. And then we fed the machine with all these parameters, pre-op and post-op data. And the task for the machine was to come up with a simple decision tree, something like this, that shows us which variables are important and which thresholds that we need to look at. So this is the output a decision tree, a simple one that can be used when consulting a patient. This was the result. Most important question, of course, minimal corneal thickness, because if you wanted to stay above the 400 micron threshold, then of course 430 was needed, because on average we ablated about 30 microns. So if you had a yes, next question is, of course, is the patient actually prepared to pay? Or can you afford to pay? And then it becomes really interesting. The system suggested as a third variable the tomographic cylinder. And as a threshold, it suggested 3 diopters. So I remind you, all these patients down here had a combined treatment, but the patients that had a tomographic cylinder smaller than 3 diopters had a 76% chance of gaining 2 lines or more of uncorrected visual acuity, whereas the ones with a larger cylinder only had a 55% chance of gaining. So the machine then suggested, okay, with this chance, you might as well do cross-linking only, whereas people with a smaller cylinder, here you have good arguments to, suggest the additional CCR. So the conclusion is a tomographic cylinder size of smaller than 3 diopters. It's associated with a high probability of improving uncorrected visual acuity by at least 2 Snellen lines. And this probably makes sense in the light that the ability of CCR to correct higher cylinders is very limited. It's a very small optical zone. It's made a transition zone. And so it makes sense, although I must confess, if someone had asked me, I would never have come up with this variable, and not even with this threshold. Maybe you got other ideas why this came up. We were interested in your views. And it's the wrong. Okay, and the second conclusion is that this machine learning approach could be useful in clinical decision making, because it is an automated determination of these variables. You don't need expert knowledge at that stage. And is also user-friendly, because the presentation of these predictive factors, you can choose to have it in this very simple decision tree. And this can be helpful and useful if you sit down and talk to your patients. That's it. Thank you. Dr. Stojanovic.
The first, very good work. Congratulations. But I was thinking immediately when I started with potential benefit to the patient, thinking about the opposite procedure called LASIK plus, which would be much more difficult to prove than you do with it. But a remark to your thing, to choose uncorrected, I don't think it's good. We want the patient to improve best corrected visual acuity, because that's the problem. So I would use my decision would be patient that cannot be corrected with spectacles, contact lenses, especially those who cannot tolerate scleral lens. These are the candidates. So medically, in my opinion, these are the candidates to do the CXL plus. And so uncorrected, is it so important? Those patients are beyond using glasses or not.
If you put yourself in the perspective of a patient, and then you as a doctor talk about laser treatment, the next question is, okay, will I need glasses afterwards? And with CCR, yes, you will need glasses. So the benefit of CCR is not that you get rid of glasses. The benefit is the glasses you're wearing
are
wearable.
Yes.
And that's it. And that's why we choose the uncorrected visual acuity. But of course, I agree.
So corrected visual acuity, I think, is the clue.
Corrected visual acuity.
Yeah. True. So if you could make another machine learning
Absolutely.
thing according to that, I think would be more realistic, because then you would get the lines of corrected visual acuity up significantly.
And of course, the difference is, we did that, of course, and the difference is much smaller, again, smaller, simply because second order problems are solved by the glasses.
So in that case, I think coma would be more appropriate than astigmatism.
True. That's why the title of this paper is actually higher order aberrations. And of course, the difference in this was huge.
Yeah.
Right, I fully agree. Maybe that you may introduce the CMI as also a further evaluation and see, because basically CMI is related to quality of vision, but also I'm sure that now that you will start with CIPTA 2, there will be even a much better difference thanks to the contribution of posterior shape.
Congratulations. Just a consideration that the cylinder really is in part a real cylinder and in part is a chromatic aberration that is a pseudo cylinder that we translate into a cylinder. So if we consider the coma aberration in this decision tree, it's better because you can see that the patients who start better ends better.
Just one related a little bit to this, but to the audience of surgeons who are in touch with that. Recently, I have seen reviewing many articles of people proposing LASIK plus. Do you have any idea? I think it's just the wrong way to go, but any other opinions? Yes. Okay, good.
Thank you very much, Claude. Now we try to connect with Massafra. Mi sentite?
Si sente?
Sì, sì,
Ok,
sì.
perfetto. Allora, buonasera, siamo in diretta dalla sala operatoria del Pagliari di Massafra. Volevo innanzitutto ringraziare il dottor Addabbo e anche l'ingegner Ippolito e il suo staff e il nostro staff degli infermieri. Il primo caso è un ragazzo di 22 anni affetto da keratocono bilaterale. Il primo occhio è stato già trattato circa un mese fa di cross-linking con regolarizzazione corneale e ha un keratocono abbastanza evolutivo, tant'è vero che poi alla successiva topografia di controllo abbiamo visto questa evolutività e abbiamo deciso di trattare appunto il secondo occhio, anche in virtù del fatto che il paziente ha già avuto un buon recupero visivo. Infatti volevo chiedere direttamente a lui, ad Alessandro. Alessandro, come va, diciamo, dopo il primo trattamento, come ti sembra di vedere?
Vedo molto meglio, soprattutto senza occhiali, noto un buon miglioramento.
Va bene, per cui se voi siete d'accordo noi procediamo, siamo pronti. Un po' di pazienza. Alessandro, quindi come l'altra volta vedrai una lucetta rossa, devi continuare a vedere sempre quella lucetta. Quella vedrai che pian piano tenderà a opacizzarsi, anche se si opacizza mantiene sempre la stessa posizione. Allora, fermo così. Fermo così. Qualche secondo ancora. Fermo. Perfetto. Allora, il trattamento è stato fatto, adesso possiamo passare alla fase di inibizione. Noi utilizziamo appunto la riboflavina allo 0,25% e faremo una inibizione per circa 7 minuti, andando poi a mettere altre gocce più o meno ogni 40 secondi, un minuto. Guarda sempre dritto, con pazienza. Va bene così. Allora, noi potremmo partire con le slide, così vi spieghiamo un attimo il caso clinico. Se passate un po' la luce qui. Passo la parola al dottor Pignatelli.
Good evening, everyone. And as my colleague already did, I would take the opportunity to thank Giuseppe Di Porto and Giuseppe Addabbo, but also everyone at the iVis Technology and everyone in our hospital for working really hard to let this little life surgery works. So, as he said, our patient is a 22 years old male with a corneal ectasis, a keratoconus. We already treated the first eye around 4 weeks ago, and those are the elevation maps of the eye that my colleague just treated. As you can see, there's ectasia in both anterior and posterior elevation map. And as expected, by the epithelial thickness map, we can see a thickening around the apex of the conus, which influence the astigmatism with up and down of almost 3 diopters. So this is the ray tracing refractive map. As we can see, we have the anterior ray tracing with the ectasis, the posterior ray tracing, which kind of compensate the anterior so that the total corneal ray tracing is better than the only anterior. And we have to keep this into consideration when we plan our treatment, because the posterior map will not change, will not be affected. And this is what he was already talking about. During the follow-up of the first eye, we realized that the fellow eye was getting worsened. This is just 37 days comparison, and we can see almost 2 diopters movement in the corneal curve. So this is the profile of our ablation. We have a kind of small refractive zone of 3 millimeters with a wide connecting zone of 7 millimeters to avoid glare after surgery, and the maximum depth of the treatment, which obviously is not on the thinnest point, is 137 micron. This is what we expect after the surgery, with a slightly anterior astigmatism that will be compensated by the posterior map. So this is the thickness that we expect after the treatment, which is all in the safe zone. And this is the ray tracing that we expect after the surgery, with this little astigmatism in the anterior map that will be compensated by the posterior. And so we will have 3 clean millimeters on the total corneal refractive map. And this is the wavefront. This is the actual wavefront. On the left and on the right, we can see what we expect after the treatment and the quality of vision that the patient that we expect to statistically increase, to significantly increase after the surgery. And I think that's all. And as you already said, we use this riboflavin solution, which is specifically designed for eyes with ectasia, because it let us use lower power for lower time with the same efficacy. So I don't know, Giuseppe, if I can't really hear anybody.
Yeah,
I hope I didn't speak alone till now.
Can you listen me?
Yeah, now I can.
Okay, good. I will just repeat. I don't know if the presentation it was clear, but basically this patient had an increase of the ectasia of 2 diopter in less than 1 month on the eye that was. Can you tell us which one are the results on the eye that you just had surgery a few months ago?
Yes, so the patient increased the dell'occhio già fatto, migliorata 6 decimi, no? It went up to 0.6 decimal without any kind of correction. But I would like to use your question to remark one thing, that beside the map and the quantity of vision, the patients are really amazed by the quality of their vision. Like after the treatment, sometimes we see a map that is not perfect, but the patient is really happy because the quality of vision and so the quality of life really increased. And this is something we saw with this patient, but with all the patients we treated with this technique. Anyway, numberally speaking, it went from 0.4 with correction to 0.6 without correction.
Thanks very much, Francesco. In the meantime, you prepare for the second patient. Now we will have the presentation from Pasquale.
Okay, see you soon.
Pasquale will give us, they just started a few weeks ago with SafeCross Plus. SafeCross Plus is the second generation of SafeCross, and basically it adds an additive which basically allows cross-linking also in lack of oxygen. Please, Pasquale.
Allora, ringrazio l'ingegnere per l'invito. Vorrei aprire questa presentazione con una citazione che per me è uno stile di vita che era presente sul mio frontespizio della tesi di laurea di medicina. Questa è dedicata all'ingegnere e noi dobbiamo cercare di convertire e non aspettare che si estinguano gli oppositori alle innovazioni tecnologiche. Bene, dopo questa, diciamo, breve un attimo introduzione, mi è stato dato il compito di parlare di una nuova riboflavina a una platea di esperti, quindi è abbastanza ardua. Prima di introdurre il concetto della riboflavina, dobbiamo un attimo rinfrescare alcuni concetti legati alle caratteristiche dello stroma corneale dal punto di vista biomeccanico e biomolecolare. Concetto di resistenza e trasparenza. La resistenza corneale è legata alla struttura molecolare del collagene. Noi sappiamo che la cornea è costituita solo dal 2% di cellule, che sono prevalentemente i cheratociti e le fibre nervose. I cheratociti determinano la produzione di alfa-collagene, idrossilasi e glicosilato, che si va a comporre in strutture elicoidali in tre catene elicoidali, formando dei legami tra carbonio e azoto. Queste strutture elicoidali si legano in microfilamenti che presentano un diametro massimo di circa 4 nanometri fino a formare la fibra vera e propria di collagene. Dal punto di vista, oltre che la composizione strutturale, è importante anche la disposizione, quindi delle fibre di collagene. La trasparenza è legata al fatto che la luce che attraversa lo stroma non viene né assorbita né dispersa. È fondamentale questa cosa perché basta pensare che la composizione della sclera è la stessa della cornea, ma cambia, diciamo, la citarchitettura. questo è ciò che si verifica in una cornea normale. In una cornea che presenta ectasia, una componente fondamentale da tenere in considerazione è la deformazione viscosa. Questo aspetto, che si chiama corneal dumping, è fondamentale in quanto che l'alterazione quindi dei legami che si presenti all'interno delle singole eliche di collagene determinano una minore resistenza allo sfiancamento indotto anche dalla pressione intraoculare. Questo aspetto è importante nella progressione dell'ectasia del keratocono. È stato visto già ormai da tempi, da più di 2 decadi, che la riboflavina, che è la vitamina B2, che è diciamo un composto fotoreattivo, in quanto esposta alla luce con una lunghezza d'onda di 366 nanometri, tende a rilasciare radicali liberi di ossigeno. Questa cosa è fondamentale perché determina quindi il principio di base del cross-link, in quanto va a determinare una formazione di questi legami tra carbonio e azoto all'interno delle singole eliche. Bene, veniamo alla nostra nuova composizione. La composizione noi possiamo, diciamo, determinare, possiamo modificare il cross-linking cambiando l'energia di radiazione o la composizione della riboflavina. Concentrandoci sulla composizione della riboflavina, questa possiamo cambiare la percentuale della riboflavina stessa, la variazione dell'osmolarità e la presenza di sostanze, diciamo, additive, quali l'HPCM, che è idrossipropil metilcellulosa, e il nuovo composto invece che è presente nel SafeCross Plus, che è l'EDDS. Questo aspetto poi lo vedremo in seguito, in quanto l'EDDS è, diciamo, il vero plus della riboflavina della nuova soluzione. Il SafeCross Plus quindi è la nuova riboflavina che è marchiata, che ha ricevuto il marchio CE, è chiaramente una soluzione sterile, altamente purificata, non irritante e trasparente, che presenta quindi la riboflavina allo 0,25%, l'idrossipropil metilcellulosa all'1%, uguale al SafeCross, ma in più presenta l'EDDS. Qual è la differenza? Che l'EDDS permette il rilascio determina quindi l'indipendenza dall'ossigeno del cross-linking, che è un aspetto fondamentale, è nuovo, è un nuovo aspetto. Chiaramente questa cosa è meritevole di studi, in quanto in letteratura al momento non c'è, diciamo, mi conferma ingegnere che al momento in letteratura, perché non ho trovato, c'è il brevetto, però diciamo dal punto di vista non c'è, diciamo non ci sono ancora dati pubblicati. Quando l'ingegnere mi ha detto diciamo di questa nuova riboflavina, in relazione alla prima diapositiva, diciamo, siamo stati subito pronti a utilizzarla, e infatti abbiamo trattato 3 pazienti 10 giorni fa, il 27 giugno, con il SafeCross Plus. Chiaramente è troppo presto per darvi degli outcome funzionali. Quello che vi posso dare sono sensazioni più che outcome funzionali. La riepitelizzazione è la stessa del SafeCross normale. La demarcation line chiaramente non era visibile, per quanto con artefizi, diciamo, questa è un'immagine modificata con i contrasti, quindi comunque si intravede, diciamo, un inizio di demarcation line. Da premettere che questo è un paziente comunque pediatrico minorenne, e che quindi io ho pienamente fiducia di questo tipo di trattamento. Per quanto riguarda l'aspetto opacità epiteliali, al momento 1 su 3 presentava delle opacità non dense, diffuse, però, diciamo, risolvibili con terapia cortisonica, diciamo, prevedibile, che statisticamente, diciamo, si verificano, quindi niente di clamoroso. Quindi questo nuovo tipo di riboflavina è un'innovazione che ci permetterà probabilmente di ridurre i tempi e migliorare l'efficacia. Sicuramente però il vero passo in avanti, come ne parlavamo prima, sarà la possibilità di customizzare l'irraggiamento, in quanto l'energia che noi somministriamo al tessuto corneale non può essere uniforme, deve essere proporzionale, in quanto che c'è differenza in un punto, cioè c'è differenza nei singoli punti. Noi dobbiamo considerare la cornea come un insieme di punti. In matematica, tra due punti ci sono infiniti altri punti, e l'aspetto fondamentale è quello di customizzare al meglio il nostro trattamento per avere il massimo risultato. L'ultima diapositiva è dedicata ai presenti della SICS, in quanto durante la light surgery mi è stato chiesto dov'è la Puglia, quindi ho deciso di chiudere. Vabbè, grazie.
Thank you, Pasquale. Just a quick further information. I mean, with SafeCross Plus, as you know, I mean, in the previous presentation, as Cosimo said, with SafeCross, actually, we are delivering 3 minutes, okay? And with SafeCross Plus, thanks to the further capability, the irradiation time is only 2 minutes. So moving in direction to irradiate as much as possible less UV. Any question? So now, if they are ready for the second surgery. If not, what we can do is okay, I will give you basically, mi dai la presentazione di adesso? I will give you before making the wet lab, so you will see the entire process. I will give you a short feedback on iRes 2, just to know which are the features. Here you have the list of the innovation which are relative to iRes 2. And the first one is basically the possibility, as for Precisio, to make auto-positioning of the patient thanks to the 6D tracking, which will drive the bed in the right position according to the information of the eye tracker, and the patient will be supported by a voice which will inform what to do, as for Precisio. The surgeon has a touch screen, which basically allow to control, of course, light, zoom, and bed movement, activate and deactivate all of the tracking. And what you see in the center is a relevant innovation on iRes 2. That's also patented innovation. You know, as you will see, iRes 2 is a very little spot. So it's important also to control the environment, and what you will. This is those buttons. They are useful to control the position of the arm, which connect the laser with the patient. But let's go step by step. So first of all, the spot size. The spot size go back. There is a specific optical path which was designed in order to minimize the spot. Actually, the spot size, and not half full width, but the entire size of the spot, okay? Because basically our competitor, they claim half full width. We are now speaking of 90% of the efficacy of the spot, and it's only 350 micron, okay? Why this is relevant? I mean, you know, in iRes 1, we already have a very little spot, round spot, but when we deal with such complex cases, especially now with CIPTA 2, with ray tracing, of course, making very particular shape, it will be benefit a lot to further reduce the spot size, to increase even more the accuracy, but also this will further reduce basically of course, thermal effect, thermoacoustical effect, because you will see that you can even not listen at all to the sound of the laser. Okay, it's so delicate that it's mandatory that basically will allow this will allow, again, as I told you, basically to optimize the beam profile, but also to reduce all of the thermal effect and basically increase regularity of the ablation. But which one is the, if we move the spot to 350 micron, this means that we need to increase the number of the spot to be delivered of a factor of 4, because basically, of course, as little as is the spot, as higher has to be the number of spots to be delivered. And the laser works at a speed of 2 kilohertz, and this allows basically to keep total treatment time, even in quite large ablation, below 60 seconds. But now let's speak about the sealed path. What you will see is that before surgery start, we have it's an extensible arm which came down and introducing a disposable, we put in one unique connection, basically the laser with the cornea of the patient. Be aware there is no suction, okay? It's no suction, the eye, it's just a protection. And overall, you will see that there is a specific window which basically creates a very homogeneous airflow to fully control plum. You will play with it and you will see basically how is really studied in a very detailed way to control the plum. You know, when we deal with so little and low energy, it is very important to basically create an environment which is fully controlled. Another one feature, question, I will finish, and then if there is any question, I will answer. Another one feature here is the capability to deliver all of the beam perpendicular to the corneal plane. And this will basically highly help in minimizing, you know, the radial efficiency problems. Exactly, because basically we use a telescopic optical system which allow to it not like this, but always perpendicular. This is also an interesting feature, the possibility to have a dynamic fixation. Why the dynamic fixation? The dynamic fixation is important because basically you know better than me that when the patient lies, not only the torsional may change, but also the angle K. And due to the reason that on Precisio, of course, we detect the angle K, moving the fixation light will allow us to restore the exact position of the patient under the laser to be in full control of the tilting of the angle K during the surgery execution. As I told you, I mean, iRes 2 will have a dedicated movable arm, which will allow to basically enter in the laser path an UV source, UV, of course, at 365, to basically customize the irradiation according to the stromal gradient. Erasmo, can you come here and put back a typical map? Last patient that we showed, let's show them how look like a customized cross-linking. I have here, don't worry. So here, for example, you see how basically the profile of the cross-linking customized will occur. You know that we deliver, generally speaking, 5.4 joule per square centimeter, wherever, and especially center of the pupil. Here, you see the map. This one map is the gradient map of the stroma. So you see that the gradient change in a very relevant way. And you see that the energy delivered in the periphery is much lower than the energy delivered in the minimum thickness of the stroma. And as we will see later on iRes, there is a diaphragm in the laser, which has a speed of contraction which is in an inverse proportion with the gradient. Of course, the higher the gradient, the faster the speed in the contraction. We will start clinical trial in September, and we expect to have iRes 2 in the market in second quarter of next year. Any question before on iRes 2? Very. You know, Luigi, your question is very important. And actually, this was just an update for all of the guys that they already work with our system. But your question is very specific and requires a dedicated answer. So let me first of all tell you that the thermal effect is really related to the total energy that you are delivering. And the larger the spot, the higher is the impact, because basically if the spot is very little, true that you go faster, but you have basically a movement of the beam which allow basically temperature to basically diffuse in a much faster way. That's the first point in favor of reducing the spot size and increasing basically the speed. But there is one more, and this is our strongest patent that we won basically. Well, I will not tell you which company, but we won a lawsuit. And basically our patent requires delivering the energy with a constant fluence per square millimeter per unit of time. What does it mean? That when basically we deliver, you know, when you start making your ablation, beginning you have a very large layer, and then you go in contraction. Now, where is the secret in order to minimize the thermal damage and improve the quality of the surface? The secret is not always work at 1 kilohertz or 2 kilohertz, but the true secret is to tune in real time the frequency of the laser head to grant a constant frequency in cornea. In other words, if you are working in a very narrow zone, you will listen now when the laser works, go down, and then it accelerates. Because the secret here, this is our most important patent in the laser, the secret here is basically to deliver a constant fluence per unit of time. Because in this way, you control completely all of the thermal effect. Okay? Thanks. So before to make the wet lab, let's look at the second surgery.
Sì, allora ingegnere, ci sentite? Ci sentite?
Mi sentite?
Noi la sentiamo, voi?
Sì, sentiamo bene ora.
Perfetto.
E ci puoi dare qualche informazione sul
Certo.
trattamento?
Allora, il paziente è un paziente affetto da una distrofia reticolare di tipo 1 e abbiamo già trattato un primo occhio. In realtà il paziente è stato già sottoposto a diversi tipi di terapie, tra cui l'autosiero, abbiamo usato anche la membrana amniotica sotto forma di collirio per delle erosioni epiteliali recidivanti. Dopodiché abbiamo pensato giustamente a fare una PTK e infatti il primo occhio che è stato sottoposto a PTK ha avuto un ottimo recupero visivo e oltre a questo anche la qualità della visione è migliorata tantissimo. Infatti, se voi permettete, vi faccio dire qualcosa direttamente dal paziente, dal signor Carmelo. Allora, signor Carmelo, quindi come è andata dopo il primo occhio, come va? Come va rispetto a come stava?
Decisamente meglio, da aprile ormai la visione è migliorata di molto, soprattutto la sera.
Okay. Quindi anche i fastidi che avvertiva si sono ridotti?
Sì, notevolmente, tutta quella nebbia che avevo intorno, poi anche il bruciore, diciamo che la situazione è migliorata di molto.
Perfetto. Allora, se voi siete d'accordo, noi siamo pronti e inizieremo il trattamento.
Prego.
Benissimo. Naturalmente, signor Carmelo, vedrà sempre quella luce rossa, quella luce poi pian piano tenderà a scomparire, a opacizzarsi. Continui a guardare sempre il punto che vede adesso. Il trattamento comunque avrà una durata breve, questa prima fase. Allora, facciamo così. Cerchi di mantenere sempre questa posizione. La lucetta pian piano scomparirà. Il trattamento comunque è breve. Mantenga qualche secondo ancora questa posizione. Benissimo. Perfetto. Allora, questa prima fase, adesso passiamo dopo allo smoothing.
Mentre fai lo smoothing, ci puoi far presentare le slide del caso?
Perfetto, sì, sì, sì.
Okay, so no, non me le fa vedere però. Okay, so as my colleague and friend Dr. Passidomo was saying, this is a patient with corneal dystrophy with both eyes. As you can see by the image, those are both complex eye. You can see the patient underwent a trabeculectomy for glaucoma, and the best corrected visual acuity is 0.5 decimal lines. And so we planned on a corneal modeling together with the PTK. Here you can see all the opacity, which are stromal, and we can see in the elevation maps that we have a central bump, irregular bump, and we also have a central hyperplasia of the epithelium, which contributes for almost 2 diopters of irregular astigmatism. And ray tracing power, the refractive map is widely irregular, especially in the first millimeter of the eye. So this is the treatment that we planned with the 5 millimeters refractive zone and a wide 8.8 millimeter transition zone or connecting zone with, in the first phase, just 34 micron of maximum depth. And this is what we expect after the surgery for the anterior elevation map. And we can see the pachymetry is going to be completely safe. And also the ray tracing is going to be smooth and regular in the first 3 millimeters. This is what we expect in terms of wavefront, so in terms of aberration in the first 3 millimeters, and we expect a really improved quality of vision. And this is it.
Thanks very much, Francesco.
Dr. Passidomo is going with smoothing, and I don't know, Fedele.
Yes. Se da là si riesce a notare come c'è una maggiore trasparenza corneale, tenete conto che quest'occhio era, diciamo, meno importante rispetto all'altro e aiuterà sicuramente a dare un contributo importante alla visione, in questo caso binoculare.
Va bene, Fedele, penso che il riflesso si vede che è molto regolare, va bene così. Grazie di tutto.
Non si sente? Non l'ho sentita bene.
Dicevamo, abbiamo visto che il riflesso è molto regolare, grazie di tutto.
Regolare. Ci mancherebbe, grazie a voi.
Una buona serata.
Buona serata, grazie a tutti.
This patient was AITCR, means that this was a pseudo-phakic patient, and if you notice it, the refraction that was calculated for the ablation was very, very minor, was plus 0.18 with a cylinder of -2, something like this. So let's now basically to complete, you will see a real process. Actually here the connection is not very good, so if there will be some delay, it will be because basically the connection is not very good. But can we make an acquisition?
But it was very good.
Absolutely. Precisio basically make 2 consecutive exams, and it's a full automated process. And actually, after the 2 acquisition, if the difference will be within the expected range, then the data will be automatically exported. So we are now introducing basically the information of the patient. Here you may introduce now all of the refraction of the patient. Vincenzo, please. Okay, go ahead. So the tracker of the device basically make auto positioning of the patient. First acquisition. Second acquisition to validate. One acquisition is 1 second, less than 1 second. 60 frames, independent frames, 1 million points basically analyzed. Now basically what it does, make detection of all of the surfaces from the anterior cornea up to the iris plane, Now he's compensating the movement, building the surfaces, make difference in between the two surfaces. And coming out with result. If repeatability good, fine. Vice versa, it will require a new acquisition. Those are the two exams. And as you see, the difference analysis. Can you show which are the parameters? Salvatore, li fai vedere tu un attimo, per favore? Vincenzo? How? Okay. Okay. Those are all of the parameters that we basically compare, and we do the analysis either from a morphological point of view as well as from a refractive point of view. And we make comparison for anterior, stromal. Go to stromal, please. Go on stromal, please. This is the difference in the stroma, and you see, and go on posterior. All of these are validated. Even only one of these was not validated, he was going to ask you for a second acquisition. Okay, go out. So anterior, stromal, posterior. Go on the pachymetry maps. You see, very regular, basically, in his case, very regular epithelium, just thinner in the, okay? And from a refractive, it's really a standard epithelium. From a refractive point of view, Vince, epitelio refrattivo. Okay? Almost a neutral value for this epithelium. If we go in the ray tracing now, we see again that the power ranges, as you may see, in about 30C. And if we go in total cornea, it's in the range of 32. Very minor astigmatism. If we go in eye tracker, we may see how much Salvatore was fixating. So go in fixation. What you see here is how basically he was fixating. So you see the blue point is from where he started in fixating. The purple circle is the circle of confusion of 0.2 degrees. So it was a quite good fixation. And let's see the movement of the eye before and after. This is the real strength of precision, is the capability. You see this movement. If we are not going to negate this movement, we could not achieve such a repeatability. If now we compensate, you see, he will tell you exactly how much is the movement. And you see now that there is no translation, but you can still notice a slight rotation because actually the compensation was only in X, Y, and Z. Now let's also make the torsional and tilting compensation. And you see now it appears that the eyelid are rotating, but now the eye is fully stabilized. So this is basically how we can achieve such information, okay? Such quality of data. Now let's export data. So the 4D suite basically allow us to export the data. He was quite fast, so he did not introduce in the medical record the data. And that's the reason why now he's asking to introduce the refractive data. So please introduce the refraction that we want to compensate. Okay? And now we go in the CIPTA design. So the second step, actually in the software we said we don't want to make a preselected value of the photopic and of the ideal, but we just want to get the data from P-matrix. So for this reason, the planning cannot start automatically because it's waiting for P-matrix. But if we would have been by default introducing, say, I want 2 millimeter photopic and 6 millimeter ideal, then we could already see the planning in the CIPTA Web. So now we are getting the P-matrix data. You know P-matrix, just for the one that they don't know this device, P-matrix basically make a dynamic analysis of the pupil in 6 different conditions and basically look at how the pupil contract to the light, starting from the scotopic until going to the photopic. Why? Because rebuilding dynamic and give a ponderal weight according to the style of life, we define all of the possibilities of the condition of the pupil during the day, and calculating the fractal of 95%, this basically allows to be sure that we are treating not more than what is needed. So this exam takes basically 3 minutes, almost. And at the end of the day, of course, this exam should be done always in a bilateral way because, you know, the influence in between left to the right. Actually, he is now in the night driving. So basically, there is a fixation lights, which basically came in front of the patient to simulate basically night driving. Then we go in close environment with artificial light, like this one. Then close environment with natural light, and finally the photopic. Almost close to finish. The last photopic condition. So now we may see the pupil dynamic. You see the contraction of the pupil, and the green, more darker area below, it's the representation of all of the condition of the pupil during the day. And basically the darker line is the ideal pupil. So now we can export data. And now the data go to CIPTA Web. So we will see basically what will happen now in the CIPTA Web. If you remember, this was, can you show, please, if the patient was, let's go connect again for a moment to Precisio. Go in diagnostic analysis. You see on top NID, so the cornea is very regular. So this patient is classified, as we said before, as NID. not irregular disorder. And if you remember, in the settings, we said, well, for an NID, we want to have 2 automatic plans, which means total corneal remodeling, which again, correcting sphere, attempted sphere, and total corneal astigmatism. And together, total subjective correction, which means correcting attempted sphere and attempted cylinder. Okay? And if CIPTA Web is connected to basically iRes 1, it automatically will switch the treatment to standard epithelium ablation. Okay? So it will be TCR-S or TCR-C. Excuse me, or in TSC-S. So we now connect to CIPTA. Considering basically a good internet connection, the time being from the data from Precisio to go to the web is roughly 3 minutes. And these 3 minutes, it's not only the data for the ablation which are transferred, but also basically all of the information of Precisio, including all of the cross-section. So you may analyze the tomography of the patient even at 500 kilometers from Precisio, because they are available in the net. And now we are here. You see, it's if you see Precisio, we are now getting exactly the same exam. It's basically was in Precisio. And of course, the exactly same exam. Of course, in a case like this, show the quality of vision, but in a case like this, we do expect that it's very regular. So a regular, very regular central wavefront, a regular PSF, and a regular quality of vision. And if we go now in the CIPTA, okay. Waiting now from P-matrix data. Question. You know, the refraction was almost irrelevant, was plus 0.5. So you see that basically was only plus 0.5 is refraction. So you see that the ablation is really a minimal ablation, is like 8 micron. And if we go on TSC, we see that they are very close, both of them, okay? Not too big difference. We can look at also the difference in between the two. And you see there is some minor astigmatism that we are making in between the two. So let's look at which one is the difference in correction. So I'll go back, Erasmo, in the refractive data. Okay, now we see we are correcting plus 0.22 with plus 0.56 in corneal, while in TSC, of course, It's the plus 0.5 that we selected with 0 cylinder. Okay. Now let's say that we do total corneal remodeling. Okay, and we can export it.
We can show the Pignatelli sex.
Yeah, okay. Here we have also the pimetric data that were imported. So you see the photopic pupil for Salvatore was 336, and the ideal pupil 477. So those data were the data that were imported in CIPTA. Okay, rounded to 4.8, as you see, the refractive zone, and of course there was no need to reduce it because it was almost not in the ablation. Okay. So now, basically, this data, they go to iRes. Erasmo, how long it will take to go from CIPTA to iRes now?
With 50 seconds. Actually, the treatment is sent to the web, and the iRes automatically download it and prepare it for execution. After this, after execution result will be sent to Precision and to CIPTA Web. And for example, in the meantime, if we can show some possibility of CIPTA Web, so there is a possibility to edit patient information that we insert in Precision. Some of these possibility we can explore with someone in our position in wet lab, and so we can also see the Precision exam with repeatability. And this is exactly the same exam that we see on the Precision. We can see also repeatability details and all the information. And the great advantage of this approach is if we think, for example, a pandemic situation where I can't go in hospital or in another center, I can work for multiple centers in one location, export the data to various centers, and go to the surgery center only for the treatment.